Thank you for joining this solid waste virtual workshop that SCS Engineers Southeast Region Solid Waste team has put together for you. My name is Saumya Bolusu. I am the Vice President and Project Director with SCS and serve as the region's Solid Waste Director. We've prepared an agenda of some really good topical diverse presentations for you today. So we hope you are able to learn from these, enjoy, and ask us questions, have a good discussion. One thing we're all trying to do is share a fun fact. You know, the presenters are going to try and do that. So I'll go with mine in the beginning. So my first job as a young teen was that of a dance instructor. I've learned and practiced Indian classical dance for over 35 years since the age of 7. So that's my fun fact. Again, I welcome everyone for joining this workshop. All right, so we start with the agenda is in front of you here. So we have 12, good presentations for you, and we'll start off with the first one, changes in Florida stormwater regulations. Take it away, Mike and Sarah.
All right, so this presentation is for changes in Florida stormwater regulations. My name is Mike Radford. I'm a project manager at SCS. I've been here almost 6 years and I have about 15 years experience in industry. And I'll introduce Sarah Perez Lopez.
Good morning. My name is Sarah Perez Lopez, and I'm a staff professional at SCS Engineers. I have 5 years of experience working for state regulatory agencies and in the private sector.
Okay, so what we're going to go over today is the main changes in Florida stormwater regulations that came up this year. So we're going to talk about the concept of net improvements, and we'll talk about the rules before and after this change, and we'll show an example nutrient loading calculation. We'll also talk about operation maintenance with the new requirements, putting together an operation maintenance plan as would be required for ERP application. We'll also talk about grandfathering provisions that has to do with the applications that are exempt from these new rules that took effect. And then we'll discuss the schedule for exactly when the rules take effect. Okay, so what is net improvement? So first, the enhancement of water quality through implementation of on-site mitigation measures, such as changes in land use or best management practices. So the goal is to demonstrate that the proposed activity or plan or whatever it is that you're proposing as a site plan will result in an overall net improvement of the nutrient parameters regulated by the state. So those two parameters are total nitrogen and total phosphorus. Slide. Okay. So prior to this 2024 rule change, net improvements for total nitrogen and phosphorus, it was only required for sites that discharge directly or indirectly into an impaired waterway. So an impaired waterway is a waterway that has a total phosphorus or nitrogen or other exceedances that the state has noted in a DEP map. So part of the stormwater management system design process was determined if the proposed site was located within or upstream of an impaired waterway. So in the beginning for the project planning, we would look at a map similar to the one on the right, and we would try to find out if the site needed to have offsite discharge, if it was going to have discharge going into one of those impaired waterways. So again, if the proposed site was located upstream or within it, we would have to look at a pre and post development nutrient loading analysis to demonstrate that the proposed project would not further degrade the water body's impairment. So again, similar to the picture on the right and on the link on the bottom, we have in the early project planning, we would look at the site and see if we're located anywhere near an impaired waterway. So Senate Bill 740 was ratified on June 28th, 2024. So this directed the Florida DEP to adopt new rules to support the goal of improving water quality in the state of Florida. So the rule updates include changes to existing stormwater management system design, operational regulations, and dam design. We're not going to cover dams in this presentation here, but again, the most significant rule change is that all sites that propose off-site discharge from a stormwater management system need to demonstrate a net improvement in nutrient parameters. Again, previously, if we had off-site discharge in our design, we were only concerned if it went to an impaired waterway. Now if we have off-site discharge in general, we have to demonstrate and show a nutrient loading analysis to show that there's an improvement. So in the picture here, this is from St. Lucie River and Stewart. This is sort of a general example of maybe what a waterway that has excessive nutrient, phosphorus, and nitrogen loading or algal bloom might look. This is like an example of what it might look like. So next slide. All right, post-rule change treatment standards. So this table breaks down the nutrient loading removal efficiencies that now need to be met by different types of projects. So for example, the first row shows the minimum performance standards that will be applied to all sites that have off-site discharge from their stormwater management system. So in summary, what this table shows is that the projects need to produce a post-development nutrient loading level that's equal to that of the pre-development condition, or that it needs to meet the total nitrogen and total phosphorus reduction efficiencies listed in this table. So basically you have two conditions, the pre versus the post, or the percent reduction of total phosphorus and nutrient loading, and whatever is the most conservative of the two has to govern. I'll show an example of that on the next slide here. But just a couple quick notes in this table. OFW stands for Outstanding Florida Water. That's a water designated worthy of special protection. That could be an estuary, a spring, or something where a water body that has very high levels of water quality. Also, redevelopment site, that's a site that has existing commercial industrial zoned area where existing land use has not been permitted, and stormwater management system hasn't been permitted at the site. So next slide here. This is an example calculation. This is meant to show a real world example using the previous table where we would have to meet the pre versus post nutrient loading or the required reduction efficiency. So calculation like this, is shown in section 9 of the applicant's handbook, volume 1. That's the DEP handbook that we use for putting together ERP applications. So this can show a step-by-step instruction on how to calculate this. But in this example, pretty much what we're showing is the case where we have to either meet pre versus post nutrient loading, or we have to have a 50% reduction. So if you could see on the third row, you have 5 kilograms per year, and on the last row, you have 2 kilograms per year. Since the more conservative load is 2 kilograms per year, that's what you would need to demonstrate that you have. So before I change this over to Sarah, basically, again, something to keep in mind is that this applies to sites that have off-site discharge. If your site has full retention design in it, your perimeter ditch system meets a 100-year storm, this nutrient loading analysis does not apply because you don't have an offsite discharge. So with that, I'm going to change over to Sarah to talk about operation and maintenance requirements.
Thanks, Mike. So the Senate Bill 740 has increased the operation and maintenance requirements for stormwater management systems. As part of these new, more stringent stormwater rules, an operation and maintenance plan that specifically details the stormwater management system components, inspection procedures, and the inspection frequency will now need to be submitted as part of all future ERP applications. Copies of documents that assign O&M responsibility also need to be provided with this new O&M plan. These documents include leases, land covenants, restrictions, and other land agreements that may assign an O&M entity that's not necessarily the site owner. A new inspection checklist was also created by DEP as part of this new rule rollout, and this inspection form has to be submitted with your O&M plan as well. And lastly, a written statement for the perpetual operation and maintenance costs of your stormwater management system will be required, as well as a financial capability certification from the O&M entity. So essentially, the O&M needs to provide proof of funding to demonstrate that they can operate and maintain their stormwater management system in perpetuity. Next slide. So these new rules now require stormwater inspections to be conducted either by a registered professional, a person working under the supervision of a registered professional, or a person that has specific background or training on conducting stormwater inspections. The inspection frequencies are going to depend on the type of treatment system that you're proposing, as shown on the table to the right. So if your site has 2 or more different types of treatment systems, the system with the most frequent inspection schedule is going to dictate the inspection frequency for your entire site. So if your ERP is proposing a dry retention basin and an exfiltration trench, the 2-year inspection schedule is going to apply to both systems because that is the most frequent of the 2. So you won't have to submit a separate inspection on year 2 and year 3. Under the new rules, the checklist that I mentioned previously is going to have to be included along with your statement of inspection. So when an ERP transitions from the 5-year construction phase to the operation and maintenance phase, that's when the routine maintenance and inspection requirements come into play. Before the rule change, your design engineer or your PE would go on site, inspect your system, and then submit a statement of inspection that was signed and sealed. Now that inspection form that DEP created has to be filled out and submitted along with that inspection certification. Essentially, DEP is just requiring a more detailed record of when, where, and why these inspections were conducted. Next slide. So the new stormwater rules aren't going to apply to a project if it falls under one of these grandfather provisions. The first category is existing ERPs. So what this means, if your site has already received an environmental resource permit, these new, more stringent stormwater rules aren't going to be retroactively applied. Another category is an application that has been marked complete by December 28th of 2025. These applications aren't going to be subject to the new net improvement rules Mike discussed earlier, but they're still going to be subject to the new operation and maintenance plan requirements and the inspection requirements I talked about on the previous slide. Another category is public transportation projects that have completed or will complete a PD&E study within 2 years of the effective date, which is, again, June 28th of this year. So these PD&E studies can take months and sometimes longer to complete. So the state is providing a 2-year buffer for the more gradual adoption of these more stringent rules for public transportation projects specifically. Also grandfathered in are future projects that are authorized under an existing conceptual permit. So if your site has received conceptual approval for future phases, when you go to apply for those future phases, your application is going to be reviewed under the old rules. So you're going to be exempt from the new, more stringent rules in that case. Another category is minor modifications, and in certain cases, major modifications, if the intent of your major mod is to bring a permitted system into compliance with your permit. So let's say you were granted an ERP that required you to construct 2 stormwater ponds, and you only constructed one of those 2 ponds, and your 5-year construction phase has elapsed. If you go back to the state to apply for your construction permit for that second pond is going to be subject to the old rules because you're bringing a site that was previously out of compliance with your permit into compliance. The last category of exempt projects are applications that have been submitted to a local government agency by January 1st of this year. So if you've already submitted, let's say, a county or a city permit, your ERP application for that associated work is going to be reviewed under the old standards. Next slide. So this rule shows the implementation schedule for these new rules that Mike and I have been discussing. As we talked about earlier, the more stringent net improvement rules aren't going to be in effect until 18 months after June 28th of this year. The new operation and maintenance plan, operation and maintenance cost estimate, and the new inspection checklist requirements have already taken effect. So if you submit an application after June 28th of this year, you're probably going to get an REI requesting these new stormwater requirements. Keep in mind that the new stormwater inspector requirements will be implemented a year after the effective date, so you still have some time to find a qualified inspector to conduct your stormwater inspections. Next slide. So big picture, there's going to be more stringent net improvement rules that are going to be applied across the board. Previously, you only had to comply with those if your stormwater management system was discharging to an impaired water body. Now, any site that discharges offsite is going to be required to provide that pre and post net improvement analysis or meet those removal efficiencies that Mike mentioned earlier. Another major change is that a detailed O&M plan is going to be required, and you're going to have to provide that cost estimate for your perpetual operation and maintenance of your system, and there's more stringent criteria on who can conduct your routine stormwater management system inspections. So key takeaways from this presentation are to try to submit your ERP applications as soon as possible to avoid the more stringent net improvement standards that are coming into effect in 18 months from the effective date. Remember that the ERP application has to be deemed complete by December 28th, 2025 to opt out of these new net improvement requirements. So allow enough time for the agency to process your application and provide comments or REIs as necessary. Keep in mind that this is going to cause an influx of applications to be submitted, so review times are probably going to be a little longer. So try to incorporate that lag time into your project planning phase, and also factor in the additional costs that these new stormwater rules are going to have on your project. Now is a good time to request pre-application meetings with your local DEP or Water Management District office to discuss how these rules are going to directly apply to your project or to your site. And remember that this presentation provides a general overview of the rule changes, but we encourage everyone to look at the updated rules in the Florida Administrative Code and in Applicant's Handbook Volume 1. FDEP also provides some great resources on the rule changes on their website if you want to follow up after this call and better familiarize yourself with the new standards. This takes us into the Q&A portion of our presentation. So if you have any questions on the material Mike and I covered, please feel free to ask those now.
Yeah, we have a minute maybe or two for any questions from the audience. Please raise your hand if you do, and I'll call on you. I guess I wanted to ask one, Sarah, I think you may have mentioned this about proof of funds, right, for O&M costs. Is that something that's typical, like a financial assurance mechanism for typical solid waste applications? Can you go over that?
Exactly. So similar to what you have to provide for a solid waste application, those requirements are not going to be applied to stormwater management ERPs. So you're going to have to provide proof of financial responsibility, essentially demonstrate to DEP or your water management district that you have a specific amount of funds set aside to be able to operate and manage and inspect and do all of the upkeep for your stormwater management system in perpetuity. So as long as your project is in operation, you're going to have to show you have the funds to provide the O&M for that.
Great, thank you. Dan, you have a question?
Hey, good morning. Yeah, if I'm a site that has no discharge at all off site, do the net improvement rules still apply if I don't have a discharge point, like I contain all my stuff on my own site?
Right, so I can take that. So if you're demonstrating that you have full retention, you don't need to show the net improvement, nutrient loading, phosphorus loading rule. That's sort of a easier way out of that rule. So yes, you don't have to show that. You do have to show the O&M changes that Sarah was talking about, but the net improvement, nutrient phosphorus reduction loading, you don't need to show.
Thank you.
Great. I think we're ready to move on to the next presentation, landfill fires. That's Layla and Stephen. Thank you.
All right, yeah, let me share my screen here. All right, can y'all see that? I guess Layla.
Yes.
Yeah, you're good.
Okay, sweet. All right, so good morning, everybody. My name is Stephen Townsend. I've been with SCS for 6 years now. University of Florida graduate. Fun fact about me and Layla is that our teams play football this weekend, and I am nervous about it. Layla, you want to do you?
So good morning, everyone. My name is Layla Alkaloff. I've been with SCS for actually my 5-year anniversary is coming up in a couple weeks, so that's pretty exciting. I have been in the industry though for about 7 years now. I am a UCF grad, and my fun fact is that UCF is going to kick UF's butt this weekend.
There's a high possibility of that happening.
We'll see. We'll see. Might eat my words later.
But all right, so yeah, let's get into it. All right, so we're gonna be talking about landfill fires. Don't say the F word. Surface and subsurface fires specifically. So let's get into it. So we want to start off with fire basics, right? So what comes together to make a fire? So you need a fuel source. In terms of landfills, a fuel source would be, your degradable waste that can catch fire, especially in dry environments. Methane gas could be another fuel used to start a fire. You have to have a heat source, right? The biodegradation of trash creates heat. And so that would be part of your main heat source, as well as, a spark in a drier environment, something along the lines of that. And then your third component of the fire triangle would be oxygen, right? Ambient air has, oxygen in it. And so all three of those together will create a fire in the right environment. So we have two types of fires specific to landfills. We have a surface fire and a subsurface fire, or as we've called it, subsurface oxidation, to try to avoid saying the word fire. There are indicators of subsurface fires and surface fires. Obviously, surface is a little more obvious. Subsurface, you're not as obvious with the indicators, but there are some telltale signs that Layla will get into later. So I'll be talking about surface fires. Indicators, again, as I said, pretty obvious, right? It's going to be immediately visible. You're going to see a significant amount of smoke and a flame coming off of the surface of the landfill. There will be a lot of potential toxic fumes and vapors coming off of that fire. So you want to approach it carefully and have a good plan. And just in terms of your operations staff, not everybody is experienced with dealing with fires. So you want to, gauge where your staff is with training and experience in this, and lead into how you're going to tackle this obstacle. So surface fire causes, right? So obviously there are a few different ways that fires can start. At a landfill specifically, hot loads are one of the bigger ways, one of the bigger drivers of fire starting at a landfill. You have some like hot coals from barbecue, cigarettes, lithium ion batteries are a big one that we've seen lately that is popping up a lot, especially with the vape pens and stuff, similar items like that. And also chemical reactions. You can have two substances that don't get along, they react, cause an exothermic reaction, and that could lead to a fire. Lightning is another one. Obviously in Florida, we have a ton of lightning. So in a drier environment, if lightning does strike and there's some smoldering from that after the rain event, you could see a fire happen from there. Vehicle exhaust and heat, and really just equipment maintenance and malfunction in general. An engine can spark, creating a fire in drier environments. And overall, your drier season is really when you're going to see the effects of the fire and your probability of your fire increasing. So you've had a surface fire. What do you do in this situation? We recommend you call the fire department. In an emergency with a fire, bring the fire department in. You need to call 911 and make sure that the fire department is available and mobilized to the site. From the site's perspective, you want to mobilize some equipment. Get equipment to the area at a safe distance, of course, but just to make sure that you can have your staff and your equipment available to help fight the fire in case the fire department needs you. Determining a plan of action, right? We want to make sure that in this situation, we have a plan, and that typically we try to let the fire professionals lead. We've heard that sometimes the fire department does not really give a ton of direction. So having that plan in place with your staff, I think, is pretty critical in remediating and extinguishing these fires. And then, of course, if you have a fire, you want to inform your regulatory agency in accordance with the permit, and you typically do that within 24 hours. So now let's talk about ways to put out the fire. We'll go back to the fire triangle here. You want to remove one of those drivers of the fire, be it fuel, be it oxygen, be it heat, right? So you can use equipment to remove material from the area, and that would be removing that fuel, right? If you have a certain, amount of material in the area that is a drier material, like some paper, something that we would see typically in our active phase, you can remove that and try to remove that fuel and stop the fire. Bringing in soil and to smother the flames over the hot area, that could be removing the oxygen, right? You want to cut off your ability of your ambient air to get to the flame. And then the fire department could use materials such as water or foam. That's removing that heat. We're going to bring that temperature down of the affected area, and ultimately that could stop the fire. All of these are just different options where, we're trying to stop that chain of reaction. We're trying to interrupt the fire from happening. So, all right, so the fire has happened. We've extinguished it. What is the aftermath? What do we want to do in this situation? So obviously an area that has had a fire, you're going to see it become a bit unstable and it might settle. So we want to make sure that our landfill owners refill this area, but do it in a strategic fashion. make sure that we're very careful in the way that we approach the area, because you don't want to have, put a bunch of heavy equipment on top of it and have it settle even further. You're going to provide a final notice and a report to the regulatory agency, listing your cause, your duration, your damage to any landfill infrastructure if that happened, and then, your plan of remediation and what was done to, bringing everything back to normal operating. And then just a lessons learned at the end of the aftermath is, we just want to look at our ops plan and see, what exactly is listed in our ops plan. Typically fire, remediation and fire remediation falls under the emergency plan within your ops plan. But do we have it in our ops plan? And maybe that's something that we can look into in the future to try to add, just so that we have contingency there. We have a plan, and maybe some training is involved in that as well, so that we're proactive in the situation of fires, because they are starting to pop up more, especially with the lithium ion battery issue. And then following aftermath, we want to think about prevention, right? I used that word proactive earlier. We want to be proactive in preventing these situations. So the placement of daily and intermediate cover, I think, is a really big part of this. Cutting off oxygen from your active face really helps with the process, because you are proactively cutting off one of those three parts of the fire triangle. I know that in class 3, you're not required to provide daily cover. You really only have to do it on a weekly basis, but being diligent in your daily cover will really help with that and avoiding these fire situations. One idea that we had was, designating areas for hot loads. Like, if your waste stream coming in, and that there might be reactive materials that won't get along per se, you can try to designate certain areas to drop those materials, let them react accordingly, and then bring it to the active phase. That way you can avoid some of this some of the reactivity within your active phase, which is one of the main fire starters. And then third is maintaining an accessible perimeter and access road. A lot of the times when the firefighters do come to the site, if they can't access the area of the fire, then they aren't really going to be much help. So we want to make sure that our perimeter roads and our access road up to the top of the landfill, and also to the area where the fire is. I know that can be tough to try to do on the fly, but we just want to make sure that in an event that a fire happens, the fire department has accessible roads and can get to where they need to be, so that they can ultimately help the situation as well. And that is it for surface fires, and I'll pass it to Layla for subsurface.
All right, thanks, Stephen. So as Stephen said, I'm going to be talking about subsurface fires, just one of those other fires that could happen at a landfill. So as Stephen had stated, this one's not as obvious, right? It's not big, it doesn't have any kind of flames. It's really just a fire that kind of happens under the surface, so it's a little harder to tell. Sometimes there are visual indicators, such as in this picture. You can see that there's some compromised infrastructure and there's some smoke coming out. So sometimes you are lucky and you can kind of see it like this, but really the key is to catch it at the oxidation phase before it actually turns into a fire. So some of the causes of this is that it can be caused due to compromised infrastructure, right? Like if you have a break in your vacuum line, that could definitely be a cause of it. Some of you guys have some plants at your site, and then you want to increase that SCFM, that collection. So sometimes you want to pull harder on the landfill to increase that SCFM value. But sometimes doing so at a very rapid pace can actually cause oxygen intrusion, and that could also cause a subsurface fire. And sometimes, as Stephen had stated, it's just the type of waste. Sometimes they just, don't get along. All right, so here are some videos for you on the left that we're going to be playing. You can kind of see some visual indicators of a subsurface fire. You're seeing some patchy grass. It's really brown. As you can see, the technician is holding a temperature monitor in their hand. He's probably seeing some elevated temperatures at the surface. And then on the right-hand side, you can see that there's definitely some reaction happening down there, right? Some smoke is making it to the surface, probably a subsurface fire happening down there. It's a beautiful sunset though. So those are your visual indicators, right? But sometimes, like I said, it's not as obvious as that. Sometimes, and where you really want to catch it is at the oxidation phase. That can be told by your data of, your wells. So some warning signs to look out for is what your well data in specific is, what you're seeing in that well data. So one indicator could just be an increase in well temperature, right? If you're above that 145 line, and you guys know your sites really well, right? If you have a well that is consistently at that 80 to 90 or even less than that mark, and all of a sudden it just jumps to that really high temperature of like 145, 150, that can be an alarm, and it could be a warning sign of a subsurface fire. What you're also going to see in your well data is, the gas quality kind of going out of that methagenic process, right? As we all know, LFG is really rich in methane and pretty low in oxygen. That's what we like to see. So if you're starting to notice that CH4 to CO2 ratio kind of shifting more towards that CO2, and then your balance and your O2 is starting to kind of increase, that could also be a warning sign. Obviously, we all know that carbon monoxide is a product of fire. So let's say you are measuring the well for carbon monoxide and you're starting to see it above that normal level. So, 5 to 100, and that's pretty normal. But if you're starting to see those numbers creep up above 250 or even 1,000, that's pretty concerning. Especially if it's over 1,000, you need to kind of take action immediately, because you definitely have subsurface fire going on. All right, so this is just kind of a visual graphic of what I talked about when you're looking at, your well data. So let's say here, we have a timeline of about from 7 or so months of data. And within that yellow window, you're starting to see that methagenic process kind of shift towards not being methagenic anymore. So, your first indicator right there on the top line is going to be your elevated temperature, right? You start to see that elevation or that temperature go up. And with it, you're also starting to see your O2 go up, which is that red line, which is second from the bottom. And you're also starting to see that methane, which is that brown line, second from the top, really starting to go down, right? Kind of getting out of that methagenic process. So that can definitely be an indicator for subsurface fire. All right. So let's say, you're reviewing your data, you're taking some measurements, and you start to see these data indicators or even the visual indicators. What do you do, right? You want to stop it right away. So your first course of action is going to be isolating the area. So you're going to want to close any wells within a 500-foot radius of your source of subsurface fire. And that is just basically to reduce the vacuum level, right? If you have an increased vacuum, then there's just more of a pathway for oxygen to get down there and start fueling that fire. Again, you want to remove one of those components of the fire triangle. You want to safely take the wellhead readings, ground temperature, and CO measurements daily, right? As you're putting this plan into action, you want to see, if it's actually helping, or, we want to see those levels go down. So we're going to want to start taking those data measurements on a daily basis. And you're also going to want to do it within a 500-foot radius, because again, you don't want to, minimize or remediate subsurface fire in one part, and then, all of a sudden now it's in another part of your landfill, right? It can migrate. So you want to make sure you're doing that within a 500-foot radius. And another thing to do is, again, to review the data in a tabular format. And of course, I'm sure, a lot of you guys use SCS eTools, but that can kind of easily do it for you. And of course, you do want to meet and maybe communicate with, us as your consultants. Will help walk you through and kind of develop an action plan so that we can get that subsurface fire before it turns into a surface one. All right, so this is just kind of a graphic depiction of that action plan. So that pink circle right there in the middle, let's say, HW9A, you're starting to see it kind of go out of that methagenic process, and you're starting to see really high temperatures and really high CO levels. So first thing to do is to close the wells in all of the area, really isolate it, kind of minimize that oxygen intrusion. So you're going to want to close all of those wells that are circled in blue there. Another thing you want to do is also turn off any valves. Again, just minimize the vacuum to the area. So if you do have some ways of closing off the valves, kind of like towards the header system, you're going to want to do that as well. All right, so another thing you can do to try to minimize the oxygen intrusion is to apply soil to the area extended about 10 feet beyond the suspected area in every direction. You're also going to want to identify and remediate the root cause, right? So sometimes it's not as obvious, but if you do see that you have compromised infrastructure within that area, you're going to want to fix that immediately. And again, just to really drive this point home, you're going to want to continue wellfield and CO measurements daily, and then you're going to want to adjust your action plan depending on what kind of data you're seeing, whether it's getting better or getting worse. And hopefully it is getting better. And once you do start to see kind of those levels go down, that subsurface fire remediated, you can slowly reintroduce that vacuum and air into your system. All right, so some proactive measures you can take. You can, it's not a requirement, but you can always do CO measurements monthly and quarterly at each well. Again, it depends on what kind of data you're seeing. Maybe there's only specific wells that you're worried about. Maybe you can just start to implement CO measurements at a monthly rate. You also always want to be analyzing trends in well field data. So, of course, everyone's kind of more concerned about compliance, but, there are some other data indicators that you're going to want to be measuring and looking out for. You're also going to want to implement a conservative well field tuning efforts. So again, some of you guys might have plants, you might have like some really lengthy goals, just keep in mind that, maybe you want to implement those goals, in a long period of time where you're conservatively tuning the well field and you're not doing anything drastic that can get you out of that methagenic process. Again, you're always going to want to minimize oxygen intrusion where you can. So you can do that by having an adequate amount of landfill cover, especially near areas that penetrate the landfill, right? Those are, some pathways that oxygen can get in. So you're going to want to make sure that all of your penetration points are nice and compact and there's minimal space. All right, so another thing to consider is just your GCCS system in general. So again, in the event that you do have a fire, you do have a subsurface fire, you're gonna want your GCCS system to be equipped with a design that is going to help you kind of control it. So, you know, what we're starting to see now and what we're starting to implement is just having a perimeter airline and a perimeter header. We no longer design, you know, when we can avoid the type of design of like the header going into the landfill. And that's just because, you know, if you go into the landfill, there's a lot of movement going on and that can sometimes compromise infrastructure over time. So you're going to want to keep that airline in the header around the perimeter. We're also starting to just do branched airlines and laterals from the perimeter header. You know, sometimes in the past, and you know, sometimes some landfills have some crossover headers where it's kind of like a looped system within the landfill. We're going to want to try and get away from that because again, if you know, we're starting to see a well and it's on a branched header or a branched lateral, then you have to isolate your entire lateral, right? Whereas if it's just a branched one and not a crossover, you know, hopefully you have a valve within that area and now you don't have to shut down, you know, more than half your system, right? You can still operate nicely, especially those of you guys who have plants. You also want to strategically place air infrastructure based on your filling sequence, right? You don't want that air infrastructure really deep in your landfill. Again, you kind of want to just minimize that air intrusion as much as possible. So try and keep it kind of close to the surface, or even better, just around the perimeter and on that branched lateral lines.
All right, yeah. So
All right.
just to you know, summarize everything and bring it back together. So we just wanted to provide some operation considerations at the end, you know, following that. Applying adequate daily cover and intermediate cover, we're really trying to hammer that one home. I think that that will really help with being proactive in mitigating fires, specifically due to the fact that we're cutting off that third part of the triangle, right? If you don't have access to oxygen, then it's much more difficult to create a surface fire. Properly maintaining GCCS infrastructure, I think it sort of harkens back to what Layla was talking about with placement of airlines, understanding where your airline runs throughout your hill. If you do have pumps, having airlines that are online and buried very deep, you know, anywhere over 20 feet can definitely be problematic because it's very hard to cut it off if you don't have proper valving. So just to reiterate that one, I think that the proper valving and proper placement of airline is pretty critical in this whole thing. Understanding, you know, landfill training or landfill fire training and spotter training. You know, for some of our bigger sites that take on multiple trucks at one time, do we have spotters watching every load get placed into the active phase? Is there a plan to train your spotters to spot hot loads, to spot, you know, different reactive waste streams? Are the waste streams that are coming in, are they being communicated to your spotter? So all of these things, you know, we want to consider when training a spotter, and also just training, you know, your landfill staff with how to address a fire. And then, you know, the last point would just be to segregate reactive materials. It sort of goes back to what I was saying there, where, you know, you want to understand the waste streams that are coming in, and if you know that some of those waste streams might be able to react, then we want to make sure that those are separated, and maybe we manage them you know, separately, and then bring them in different sections into the active phase so that we can try to avoid some type of reaction. And I think that really covers it. And if there are any questions, let us know. And if not, thank you guys for your time, and you know, we really appreciate it.
Any questions for Stephen and Layla?
Dan?
Oh, yeah.
I'm the question guy today. It's more of a comment, I think. You mentioned the air isolation valves, because I think, the air line is often a lot of times the source of the subsurface, oxidation. Just for this group, we're often trying to cut costs and things, but the air isolation valves, I think, are less than $1,000 a piece, and maybe even, half of that. And so having a few extra valves to shut off your airlines and not have it go through a particular area that could get deep is so much worth, spending that money when you're doing your GCCS construction, because of exactly this. If you don't have the valves and you have to shut off, 80% of your hill, and then your pumps go, start, being overwhelmed, and the wells don't produce, and it just leads to a bunch of other problems. So these what sometimes seem expensive, but if you have them and implement them early, they can really cause you save you a lot of problems later if you ever have an event like this. So that's just a comment.
Donovan?
Yes. So my question is going back to like the lithium ion batteries being in landfills. After this recent hurricane, we saw a lot of Teslas blowing up with the water and stuff. What are some ways that, we can't control what people are throwing away? What are some ways that landfills have been trying to isolate certain waste streams coming in?
Yeah, I mean, I think that's a good question. And I think it could go back a little bit to our segregation thought, where, if you are receiving a waste stream that in particular is going to have a lot of the lithium ion battery within it, maybe it's something that you put aside and you try to deal with it in a separate manner. I know that with some battery, going into the future, right? There's going to be recycling initiatives and things that are going to be implemented, I would hope, to maybe try to reuse some of these materials in the future so that all of it doesn't get landfilled. But overall, I think that it's a pretty good question. Layla, do you have any idea with that?
Yeah, I think it definitely does go back to segregation, but even further, I think, just educating the public on what to throw away and what not to throw away, right? That's really what it comes back to. A lot of you guys here on this call, I know you go through extensive efforts to educate the public. Some of you guys do school reach outs, or even do, little presentations for the community. So I think that's also another way to minimize it, just really educating the population.
All right, thank you guys. Great presentation. We'll keep moving on. So the next one is Trent, who's going to present about composting fundamentals.
I guess while we wait for Trent to join, so sorry, I think we missed a question. It was by Weston. We want to answer that really quick. Their question was, are there safety considerations when subsurface fire is suspicious? There is one that kind of is one that maybe Stephen had touched on with surface fires, but subsurface fires, it is still a fire underneath the surface, right? So you can still see some cave-ins happening. So, if you are able to isolate it to a specific area, definitely, try and kind of keep a safe distance, because it still can, cause a little bit of a cave-in as that waste is shrinking underneath ground. I think maybe that would be the biggest safety consideration. Do you have one, Stephen?
Yeah. I would say just limit access to the area in general, right? Because of what you're talking about with looser cover soil there, potential for cave-ins. Additionally, you might see elevated surfaces at the temperature or elevated temperatures at the surface, even though, right, it is below surface. You're still going to see, and in that video we showed, you could see some of the heat coming off the surface, right? I mean, we've seen at some other facilities where people would walk over areas of SSO and their boots might start even to melt. So limiting access to the area is probably the most critical safety consideration. And then, obviously going through the steps of trying to remediate.
Sorry, Trent.
No, you're fine. Thanks. No, I did the embarrassing Teams thing where I did my whole introduction and then realized I had muted myself.
You would think after a few years we'd get that right.
You would think.
Still happens.
It still happens. Well, round two. Good morning, everyone. My name's Trent Arney. I'm an engineer here at the Tampa office with the solid waste team. I've been with SCS for a little over 5 years. And along with my usual solid waste work, I also do composting and system design and education. So today I'm just going to kind of cover the what's, the whys, and the hows of composting, just kind of a broad overview to understand the process and how that might fit in with your operation. Okay. So to start off, we're just going to kind of talk about what the composting process is. It's a biological process, means it's dependent on microorganisms. These can be naturally occurring, or you can include inoculants in your piles to speed up the process of composting. It's going to depend on the input of organic materials. So it's going to be a mix of your feedstocks and bulking agents, and that mix is going to be very important. And I'm going to touch on that a little later, but that's going to be where you have the greatest control in the actual product you're producing. It's an extension of natural decomposition. So we're really just taking the natural process that occurs and we're controlling it and accelerating it so that we can produce a reliable and consistent product in a timely manner. So I'm going to kind of take an opposite approach of what Layla and Steven were just talking about. And I'm actually going to talk about the importance of including oxygen and preventing methanogenesis in the composting process. It's heat generating. So, your piles are going to increase in temperature. And that's going to help to break down some of the harder to break down materials like, your cellulose, your lignins, etc. And your goal at the end is to produce a stable or mature compost. So that means that your compost product at the end, all kind of microbial decomposition has ceased and you've produced a stable compost that's free from pathogens or any other contaminants. So why do we care about aeration so much in our composting system? So with oxygen, otherwise known as aerobic respiration, you're going to use oxygen as your primary oxidizing agent. And this is really what composting is. Without oxygen or anaerobic respiration, you're going to use inorganic substances other than oxygen to oxidize. So, acetic acid, lactic acid, ethanol, methane. Okay, well, all of those don't have a particularly pleasant odor. You ever walk by one of those nasty kind of swampy puddles? We don't want that in our composting system, and I'm sure your neighbors will thank you as well. So some of the biggest advantages of really promoting aerobic decomposition is it is one of the fastest ways to establish stability in your product. You're releasing more energy for your bugs to consume. You're producing a more complete reaction. It means your feedstocks are breaking down more thoroughly and you're producing a more uniform product. And generally, it creates fewer odorous products. Some feedstocks, regardless of how well you aerate your pile, they're just going to have an odor. Something like, say, biosolids or agricultural byproducts like manure. Those are just going to smell. There are ways that you can mitigate that. So your basic phases of aerobic composting, you're going to kind of start with this rapid acceleration, and that's kind of when your bugs are really starting to grow. And that usually lasts a few days, maybe a few weeks. You're going to see a rapid rise, but then you're going to hit this hot and rapid thermophilic stage. This is really where the majority of your composting and all of the breakdown of organic material takes place. So this is going to be between a few weeks and a few months, just kind of depending on what feedstocks you're including and what your process is. And then after that, you basically can just let it cure and mature, and you really want to keep those temperatures monitored because, again, just like with anything else, we want the temperature to be high, but there's such a thing as kind of a runaway temperature where essentially your bugs just keep reproducing, that temperature keeps going, and eventually it can get too hot, which can cause problems for the bugs themselves because the actual beneficial bugs have a healthy temperature range. Once it exceeds that temperature range, usually around 170 to 180 degrees, you can kind of start to slow down your process and also increase the odds of potentially having a fire in your pile, which nobody wants. So why do we care about composting? Why are we talking about composting? So it can help with a number of things. It can help you to divert troublesome waste streams like biosolids, animal mortalities, yard waste. I know here in Florida, we get a lot of hurricanes and tropical storms. Ends up with a lot of yard waste that's in need of disposal. We don't really want to put that in our landfills, so it's a great thing to include in a composting operation. Biosolids are much the same. You know, every county, every state produces biosolids. They have to be disposed of. But as all my landfill operators here will say, nobody really loves taking biosolids in their landfill, and composting is a great alternative to landfilling. Can also help improve public image. There's been a huge push lately for green initiatives and renewable and all of that lately. And so I think it's really good to show that, hey, we're taking all these, nasty wastes like biosolids, and we're taking all this yard waste, and we're generating a usable product that can help you to support local agriculture. Can also help to lower greenhouse gas emissions. On average, the composting process produces less greenhouse gases than your typical landfill decomposition. Can also help you to prepare for potential regulations. Depending on which area of the United States you live in, there are kind of creeping regulations across the country that are calling for either partial or complete bans of organic waste disposal in the landfill. And so it can kind of help if you feel like you're in one of those areas that might be getting regulations soon. It can kind of help you to go ahead and establish that process so you're ready, when the time comes. So as far as the composting process is concerned, there are really 6 key factors that we need to consider. Number 1 is going to be your feedstocks and mix ratios. Again, I'll say this multiple times. This is incredibly important because this is your greatest source of control for what product you're putting out, what your odors are going to be. It's incredibly important that you understand your feedstocks and your mix ratios. Moisture content is also very important because that's going to help to drive the decomposition process as well as keep making sure that your pile is, maintaining a good quality moisture content. Oxygen and aeration. I think we've already touched pretty heavily on the importance of, aerating your piles. But again, I included it. Just want to reiterate, it's very important that you don't allow your piles to go anoxic. Physical parameters. So, when you're considering your feedstocks coming in, if you have a dense feedstock, such as, manure or biosolids, you want to make sure that you're really pairing that with the appropriate amount of ground yard waste, wood chips, something like that. Otherwise, you're going to end up with a really kind of claggy, dense mixture, which is very difficult to apply. The same is true on the opposite end of the spectrum. When you're considering, feedstocks that don't have a lot of density, say pulp and paper products, etc., you want to make sure you're pairing that with a denser feedstock so that you're maintaining that proper density. Because the goal, again, is to create a stable product, but also a product that's easy for the people you're selling it to actually apply to their fields. And, that's really key to maintain that proper density. Time and temperature. Got to be patient. Composting is not an incredibly fast process, and it takes time to get a quality product out the other side. Really don't want to rush the process so that you can maintain that consistency for your customers. And temperature. Again, it's important to monitor your temperatures. Your temperatures are going to get relatively high, but you want to make sure they're staying within that stable range, typically around 130 to 170, because that's going to be really where the peak of your microbial activity is going to take place. So let's go a little deeper into the feedstocks, mix ratios, and moisture content. Again, you have the most control of your final product here. Understanding what your feedstocks are going to be, whether that's going to be animal byproducts, biosolids, pre-consumer, post-consumer food waste, understanding potential contaminations, and maintaining consistency in your supply is really key to producing a quality product. And as a part of the mix ratio, what you're really targeting is this carbon to nitrogen ratio. So that's going to kind of give you the ideal nutrient balance for kind of agricultural applications. So your carbon sources, that's going to be kind of your woody waste. And then your nitrogen sources are going to be more like food waste, biosolids, manure, things like that. So it's really important that you get the right ratio. And in general, the target ratio is typically around 20 to 30 to 1. It depends on your application and what end result and what market you're selling your product to. But typically that's really the goal. Again, clearly define acceptable materials. So once you've established what kind of composting operation you want to go for, you've got some vendors lined up, clearly define what is acceptable. It goes back to what Stephen and Layla were saying. We want to really reduce the kinds of contamination that can give you a product that, maybe requires more post-processing on your end, more time, more money, or is completely contaminated and you have to scrap the whole load. So we really want to make sure that we're clearly defining it and we're maintaining consistency. Overall moisture content really plays a huge role in your quality. Typically, you want to aim for around 45 to 55% by weight, but that can vary by region. The drier regions, you're going to want to start off with a higher moisture content, maybe 65+%, because you're going to lose moisture as the process goes on. Somewhere down here, like at Florida, you don't usually need to target such a high moisture content because it's damp in Florida. You can just about drink the air. You can test this just real quick in the field by just grabbing a handful of your compost, giving it a good squeeze. If it forms a ball, but no excess drips out, it's probably pretty close to where you want it to be. And it's just a little table that kind of just summarizes kind of what happens. Like usually when you fall below 35%, you can pretty much halt your process. And at that point, even adding additional water, it's going to take a long time for your product to really start jumping that aerobic decomposition again. So talking about time and temperature, this is really the takeaway as to why we care so much about time and temperature. So there's this kind of criteria that the composting industry has come up with that kind of is this certification that basically proves to your customer that we have followed the proper procedures and, this product is going to be free from standard contaminants and weed seeds. And that's called the PFRP, or the process to further reduce pathogens. So it's going to vary a little bit based on what methodology you're going to use for your operation. And I'll touch a little bit on some of those kind of different methods. But in general, your target is above 131 degrees Fahrenheit. And for an aerated static pile system, that's where you're forcing oxygen through your piles. It's going to be 3 days. And for a turned windrow, that's going to be 15 days. And you have to turn it at least 5 times. The average time to complete your product, it's going to range. The aerated static pile tends to be relatively quick. Turned windrow is going to be a little bit more in the middle of the range, but typically you expect 3 to 9 months for a finished product. And it will take time, so be patient. You're going to have to dial in the best time for your operation based on your feedstocks. It's going to take a little bit of trial and error, but once you dial it in, as long as you're maintaining consistency with your feedstocks, you're going to be good to go. So some general common goals, like I said, you need to make a high quality and consistent compost, and that goes back to understanding what feedstocks you're taking in. It's important to create that consistent product because that's going to keep people coming back. You're also going to need to comply with regulations. Check your local regulations, county regulations, all kind of local variations are going to have an impact on how you have to design and consider for your operations. But in general, you want to watch odors, air emissions, and if you're doing something like post-consumer food waste or biosolids, you're going to have to follow the typical regulations for solid waste management. Here in Florida, that's 62709. But yeah, so you need to be cost competitive. So you need to think about, okay, where is my facility located? What is my target market? What are the needs of my community? And you need to kind of set a cost based on that. You don't want to set a cost that's, 5 times higher than Home Depot compost or something because, okay, well, then people aren't going to be as inclined to use it. So you really want to keep that cost competitive. So next, we'll just kind of touch on a few of the most common means and methods, some common equipment, just to kind of go ahead and get your composting started. So just some basic equipment. So there's going to be a couple of pieces of equipment here that are, well, they're kind of like that kitchen gadget you see on infomercials that has exactly one use. Yeah, a lot of these equipment are exactly like that. Primarily the windrow turner. It does exactly that. It turns windrows. That's all it does. But it exists because it does it incredibly well, better than pretty much any other way that you could turn your piles. It's a one-trick pony, but it's a great investment if you have a large-scale turned windrow system. Grinders are a little more commonplace, but that's just used to go ahead and break down some of the larger pieces of yard waste or kind of debris or anything like that into more manageable pieces that are easier to break down for your bugs in your composting process. And finally, the compost screener. It's another one-trick pony. It does exactly what it says it does. But again, this all just goes back to maintaining that consistent quality product. Screening to a specific size is really going to help you to target specific customers and also maintain a consistency because you are screening to a specific size. So the first composting system we're going to talk about is turned windrow. That's aerated via natural convection. So essentially you're just relying on the heat released from your pile. And as that heat is being released, it's drawing in air through the bottom of the pile that's maintaining that 5% oxygen. Again, you're going to turn with the windrow turner, or you can use kind of a bucket loader if you have a smaller operation. But the real idea with turning, it's kind of twofold. One, you kind of introduce this burst of oxygen into your pile. And two, you're basically mixing all the material from the outside edges of the pile that maybe is not getting as hot and is not as active microbially. And you're putting that back on the inside to make that consistent final product. It does take a larger footprint than some of the other methods we're going to talk about. You've got to have it spread out in these windrows, and you've got to have curing areas. You've got to have your active composting areas. So it does take up a large footprint, but if you have the area, it's the tried and true, most common method for a reason. It works, and it works well. Static pile composting is a little bit different. This one kind of takes all that I said about aeration and throws it out the window. Typically, this one has very low oxygen, sitting around 1 to 2%. It's a very slow process, sometimes taking, over a year to complete. But the idea with this is great for small scale or animal mortalities or kind of a set it and forget it kind of composting system. Basically, you build the pile, you put your base layer down, you put that cap of ground yard waste or, compost that you have finished. And that really helps to prevent the odors from escaping. At that point, you just kind of set it and forget it. Like it's slow, but it works. It just takes a long time. Aerated static pile. This one is definitely up and coming. This one is where you take a blower and you either force air through the pile through these perforated pipes, or you pull air through the pile and then out the other side. They're pros and cons to each method. I think where you pull it through the pile, I think that's really good for areas where, you need a compact operation. Maybe it's a little more urban. Maybe you have a little closer neighbors and you really want to manage those odors. Pulling the air through the pile allows you to then filter that air through either screened compost, wood chips, carbon filter, and really help to control the odors that you're emitting. It's a higher temperature and it's a faster process, and it can be done on a much smaller footprint. So again, this is great for compact sites or sites that are in more urban areas. In-vessel composting is a great option for smaller spaces, universities, or community composting or small on-farm composting, or even just a proof of concept for composting certain feedstocks. It's typically a fully or partially automated process where you load your waste in the case of this world heating drum, you load your waste in one side, your mix, and it just kind of slowly makes its way down this drum until it comes out the other side. And so all of your primary composting process takes place within this drum or a kind of a concrete bunker with an auger that keeps it mixed. It's great process control. It's, mostly enclosed. So, you're preventing any environmental contamination, and you can control temperatures, aeration, and it can be scaled. I've seen incredibly large facilities that use this kind of bunker and auger system, but typically it's used for smaller scale operations. But it's important to think composting can be profitable. This can add value in more ways than just generating revenue, especially for municipalities. You know, if we're talking biosolids disposal, this county that I took this graph from generated over $1.2 million annually in net revenue improvements. It's a 59% savings from what they were paying to dispose of their biosolids and a 16% savings what they were paying to dispose of their yard waste, as well as generating 25% of that from their actual sale of their product. You can generate revenue both from tipping fees and from the sale of your finished products. So you kind of get to double dip there a little bit. All right. So that's just kind of a rough overview of composting, kind of the process and how you can go about it. So yeah, I'll open it up for questions now.
All right. Thanks, Trent. Appreciate your presentation. If you guys have any other questions, feel free to ask now. If not, we'll move on to the next presentation. Right. So the next presentation we have is what does your groundwater data tell you? Miles and Sarah. Thank you.
Good morning.
Good morning, everyone, and thank you for joining us. My name is Sarah Borges. I'm a staff professional at SCS Engineers and have been with the company for over 3 years. We also have Miles Cluner with us. Miles is a project director with SCS and has over 20 years of permitting and water quality monitoring experience at solid waste facilities. And today we'll be discussing what your groundwater data is telling you. Here are the topics we'll be discussing today. We'll start with explaining the basics of how and why your monitoring system was established and go over your basic requirements for routine monitoring. Then, once you understand that framework, we'll dive into what your actual data might be telling you about your site and your operations. This data will be vital to understand what steps need to be taken towards addressing any items, protecting the environment, and avoiding any costly additional investigative and corrective actions, violations, and more. So we assume that most of you are already dealing with the existing solid waste facilities, but it's still important to know how your water quality monitoring system was established. At the time of initial design and permitting of your landfill, a hydrogeological investigation is performed to identify any subsurface features at your site. It's important to understand the aquifers and possible confining layers or breach zones underlying your site, which may affect the need for multi-depth wells in your system. The initial field investigations will involve literature reviews, installations of borings and piezometers across the site. The piezometers will be monitored over an extended period of time to establish your seasonal high water elevations. That would be used to design your monitoring well installations and even your landfill base grades. The groundwater flow across the site is also determined at this stage. This is important to know because it can dictate the need for higher frequency of sampling in order to identify any potential contaminants that may be released from the landfill. For example, if the flow velocity across the site is really fast, then the concern would be that by the time you detect any contaminants, there may be already be a plume extending pretty far from the facility. So at this stage, early detection will be critical to determining any issues in a prompt manner. Another key step to the hydro investigation is establishing your background water quality This data tells you water quality prior to any solid waste operations, and it could be used in the future to compare against detections in your monitoring system. For example, if the concentrations of certain parameters were elevated prior to establishment of a landfill or a new cell, then future exceedances can be demonstrated as pre-existing conditions. So once a hydrogeo is known for a site, your monitoring system is designed. One thing I'd like to point out in this discussion is that we'll be focusing on Florida regulations, but many of these also likely relate to other states as well. So several key factors must be established to be incorporated into your monitoring plan. A zone of discharge is established for the site based on your cell layout. So the zone of discharge is defined in Rule 62-550 of the Florida Administrative Code as a volume underlying or surrounding the site and extending to the base of specifically designated aquifer within which an opportunity for the treatment, mixture, or dispersion of waste into receiving groundwater is afforded. So essentially, the FDP recognizes that any type of large development, such as landfills, shopping centers, parking lots, will affect the hydrochemistry of the groundwater as rainwater infiltration is cut off and changes begin to take place. So the zone of discharge allows for processes to occur near the vicinity of the landfill. So based on the groundwater flow direction across the site, you'll establish your background wells, detection wells, and if needed, your compliance wells. And by Florida rule, the background wells are required to be spaced no more than 1,500 feet apart, while the background or the down gradient detection wells are to be spaced no more than 500 feet apart. And for C&D facilities, the rules only specify a minimum of 1 background well and 2 detection wells. Now, the detection wells are situated from the limit of waste, as shown in the figure, and it's typically within the middle of the zone of discharge, which will allow for early detection of impacts. And compliance wells, if needed, are placed at or beyond the zone of discharge. So now that your monitoring plan has been established, you'll want to comply with your routine monitoring requirements. The sampling frequency is dependent on requirements outlined in the regulations and also the site's permits. Frequency and sampling can vary, but it's typically done on a semi-annual basis. And then the routine parameters are also dependent on the type of waste placed in the landfill and the type of facility. For example, a C&D facility has different sampling requirements than an MSW landfill. Now, prior to sampling any wells, a depth to water survey is performed at the site in order to establish your groundwater elevations and the flow across the site. Presented here, we have a typical contour map, which shows a northeasterly flow across the site. So therefore, the MWBG wells along the west and the south side of the facility are the background wells, and the MWD wells along the north and the east side are the detection wells. There's also compliance wells at this site located on the northeast corner, just north of MWD3. So once you've sampled your groundwater at the site, you'll want to look closely at your data. There are many potential sources of impact to groundwater quality at a landfill, but we'll be discussing more of the common ones, which can be broken down into the following categories. The first being leachate, which can include plumes from older unlined sections of your landfill, breaches in the liner, seeps, which can be carried by rainwater into your perimeter surface water management system swales and percolate down into the ground. And also damage infrastructure outside of the landfill footprint, such as leachate force mains. Landfill gas, similarly to leachate, can be from old unlined areas, liner breaches with high gas concentrations in the lower portion of the landfill, damaged header pipes, or other exterior GCCS components and condensate. historical site uses, such as a former gun range, former lake filling or dump site, and even agricultural uses have impacts on the groundwater quality. Naturally occurring parameters, such as iron and arsenic, can be naturally elevated throughout Florida, so we'll typically see those a lot. Another source could be hydraulically upgradient, such as leaking underground storage tank at a neighboring facility, upgrading of your site. You could also have bad data, could be an issue during sampling collection, such as high turbidity, which could result in elevated metal detections. And you could also have issues with the lab, such as cross-contamination of samples or residual cleaning chemicals. So these are all things to consider when you're reviewing your data. And now I will hand it off to Miles to continue on the discussion.
Thank you, Sarah. So now let's look at some examples of what your data can tell you. You need to look at the parameters that are elevated and those that are not to determine the causes. If you see elevated sodium, chloride, and total dissolved solids, this might point to a municipal solid waste impact. Generally, certain parameters will trend together if you're dealing with particular sources. For example, we'd not expect to see sodium spike up and chloride, total dissolved solids, and ammonia stay low. If you do, then the spike's likely not an indication of a landfill leachate impact. This could be lab error or sampling cross-contamination. This graph demonstrates expected trending of similar parameters. You can see the sodium and chloride and ammonia all increasing together, decreasing, and following a similar trend over time. If you see elevated ammonia, sulfate, and aluminum, for example, with lower sodium and chloride, this is more likely a construction and demolition debris impact. These are the common contaminants that can leach out of concrete and drywall components of construction and demolition debris. If you see elevated volatile organic compounds, such as benzene, toluene, vinyl chloride, but see low concentrations of sodium and chloride, this might point to a landfill gas impact. You want to consider additional testing, perhaps, for dissolved methane content in the well to provide further assessment into the cause. Please keep in mind that presented here, this is not an all-inclusive list, so look at all your data. It's important to note that you should not just compare your data to regulatory standards, but also look at concentrations in relation to background water quality, meaning data prior to waste filling or in your hydraulically upgradient wells, and also look at the water quality data from prior monitoring events. Look at trends. Each parameter tells a story, and if you put the pieces together, you can solve this mystery. Next, it's important to look at where you're finding these elevated concentrations. The spatial layout and range of concentrations can point to the source. This can most easily be completed by creating a figure, basically a visual representation of groundwater quality. Presented here is an ISO concentration contour of a possible scenario. This figure shows fictional sodium concentrations at this site. This mounding up here in the northeast corner is clearly directing us to a specific location where these elevated concentrations are originating from. This directs the landfill operator on where exactly to investigate. And based on your findings, the appropriate repairs can be made. Another approach to identifying a groundwater contaminant source is to perform a geochemical analysis. There are many different methods for this depending on the types of contaminants you're investigating or the potential source. For example, if you're dealing with elevated metals, you might first want to look at reducing turbidity during your sampling, and then then perhaps test for dissolved metals in your analyses, or investigate possible redox potential, which is a reducing or oxidizing environment that can result in dissolution or release of naturally bound metals in the soils into the groundwater. Certain parameters can be plotted against each other to see if there's a correlation. In this example, several parameters are plotted against sodium concentrations represented by the x-axis. For strong correlation, we'd expect to see a comparable increase in concentrations between the parameters. So for example, a line from the bottom left of the figure to the top right of that graph. And we see that in this example between sodium and chloride represented by blue. But there's not as strong a correlation between these other two, the benzene and vinyl chloride. And similarly in this graph, we're not seeing a strong correlation with the barium. Another approach is to do more detailed fingerprinting analysis. By analyzing for cations and anions, for example, we can do a more complex approach. This is particularly useful to see if there's a leachate fingerprint in groundwater. In this example, we had expanded a monitoring system for construction of some new cells at a landfill, and we were finding elevated arsenic in many of these new wells at the site. Because filling operations hadn't initiated in this area, we suspected an alternate source for the arsenic detections. We ran an expanded anion and cation parameter list, and we were able to look at the data in two different ways. First, we generated a stiff diagram. This diagram is a polygon created from horizontal axes, 3 axes on either side of a vertical axis. Cations plotted on the left, anions plotted on the right, and a greater distance from that vertical axis represents a larger ionic concentration in the sample. The cation and anion concentrations are connected to form an asymmetrical polygon, which is referred to as the stiff diagram, where the size is a relative indication of the dissolved solids concentration. As presented in this diagram, the leachate polygon, which is this top left corner purple one, has a very distinctive polygon shape that's not evident in any of the groundwater samples, which are represented by all these other polygons here. And this suggests that there is not a significant leachate impact on groundwater. Next, we generated a trilinear, or also known as a Piper diagram. In this diagram, cation and anion concentrations for each sample are plotted as their percentage of respective totals in the bottom 2 triangles. And these relative percentages are then projected into a quadrilateral polygon on the top center that describes the water type or hydrochemical facies. As presented in this diagram, the leachate sample, which is this red dot, does not plot near all the groundwater samples, which are all plotting in the same general area, indicating a different geochemistry. This again suggests leachate's not significantly impacting groundwater at the site. By doing this analysis, we're able to demonstrate that the groundwater had a very different fingerprint than the leachate, and thus, in conjunction with some other analyses we performed, we were able to show that the elevated arsenic concentrations in the new wells were not due to a landfill impact, but rather were attributable to naturally occurring or redox concentrate conditions. As we wrap up, there are a few key points we wanted to stress. We strongly recommend you don't just treat your groundwater monitoring requirements as simply a checkbox item. Your monitoring program is an indicator of the environmental protections you have in place at your facility, such as your liner system, your GCCS. Pay close attention to your data, understand what it's telling you. And you may need to repair a faulty item or perhaps even change your operating practices. Be proactive. Look at what parameters are elevated, where you're seeing this, compare to other locations or historical data, and look for trends. If you see early indications of an issue, look into it before it becomes too late and you have a plume leaving your site. At that point, the repercussions are significantly more serious and the issues are harder to address. You could be facing further investigation, corrective actions, or possibly even worse. And finally, we recommend you protect your system. Far too often, we see these wells damaged in the normal course of operations or during construction at the site. A damaged well that's not replaced can potentially lead to detection of more exceedances, as soil particles, for example, can enter a damaged subsurface screen, and you might not even be aware of this, but you will be getting hits. So repairs, of course, can also get costly. We've covered a lot of information in this presentation, some just superficially due to limited time. After a short break, there'll be another presentation on groundwater coming up next that will provide a case study touching on many of these items that we discussed here. We'd be glad to answer any questions you may have on this topic, either now or via email or phone in the future. Sarah and my contact information are presented here, and we appreciate your time today, or would love to answer any questions you might have on this topic. Thank you.
So you heard from Miles and Sarah, so now I'm going to be kind of building off of that. My name is Fove Hearn. I'm a staff professional here at SCS. I've been here almost 4 years. I was supposed to be co-presenting today with Whitney Rodriguez. However, due to the hurricane, she was not able to join us. So it'll just be me presenting, but I have included her contact information for afterward. My fun fact is that I have a bucket list of hitting the national parks. So far, I've been to 31, goals to hit all of them. Think I'm doing okay for now. Okay, let's get into this. So we're session 5, uncovering the hidden groundwater investigation and management at landfills. So the flow for this, the agenda basically is kind of building off of what Miles and Sarah had talked about regarding groundwater monitoring, and then getting into some case studies that dive into the now what. What happens when you have an exceedance or a high detection in your groundwater results? So just how we listened to Miles and Sarah, this is kind of a brief discussion on kind of the background of it. So you already have your groundwater monitoring plan in place, you're in the rhythm, you're doing a semi-annual sampling, you're doing the lab review, you're doing reporting, the submittals to DEP, you have that rhythm, that flow going. But now you received a lab report from your previous sampling that says that there's a detection. It's not something that you have been experiencing when the rhythm and the flow, and now you kind of are trying to figure out what to do next. And that's where this conversation picks up. So some background, some leachate indicators are common parameters that can be found in your groundwater results. Miles and Sarah kind of talked about this a little bit more, so I'm going to be a little brief on it. But basically, of your leachate indicators, which are your ammonia, your chlorides, your sodium, that can be found in your groundwater. A lot of times this can be due to landfill impacts. You have damage to the landfill liner, you have a seep, you have damage to the leachate collection system. Over time, this can lead to leachate entering into a groundwater system. So the most important thing about this is that making sure that you have that communication between your operators, the clients, or the site managers to determine, hey, was there damage during any type of operations daily at the landfill that allows you to get proactively ahead of any issues that could happen when groundwater reporting comes about. So then you have metals. Metals in groundwater are common in Florida due to the type of soil that exists. You have the limestone, you have all the different metals that can exist already in your groundwater and your soil systems around Florida. However, with a landfill, it can also be a similar pathway through leachate from the landfill entering into your groundwater system. But most of the time, it's generally due to some form of redox reaction, as Miles had mentioned, that takes place in the soil or around the soil-water interface. And a lot of times this can lead to metals that are already present in the natural environment becoming mobile and entering in your groundwater, which enters into the groundwater wells, which becomes a detection. And it could lead to a spike in, magnesium or arsenic or iron, which if you're not monitoring it, you could attribute that to leachate or landfill impacts, but it could also just be due to naturally occurring reactions within your soil. So then you also have volatile organic compounds, or VOCs. This is your vinyl chloride, your 1,1-DCE, benzene, basically your BTEX chemicals. Generally, this is due to landfill gas, as Miles and Sarah had mentioned. And landfill gas can migrate from the landfill into the groundwater through advection, diffusion, basically allowing the transfer from solid to air to liquid, and all those different mechanisms to allow for gas to enter into the groundwater system. So basically, we're at the point now of now what? You have been doing your routine semi-annual sampling, your quarterly sampling, however it's stated in your solid waste permit, and you notice that, say, iron is above normal levels that you have been tracking at your site, or you have sodium at a high level. Now what? Basically, this is where our conversation picks up. We're going to start figuring out how SCS has helped a lot of different clients move on to addressing these issues. So basically, first you can compare with historical site and background data, reviewing lab reports, determining what is going on. Was there an issue with the reporting from the lab? Is this in line basically with historical background data, or is this more a first-time exceedance? Is this a trend that you've been tracking? Kind of going through those questions and asking is this normal for my site? Is this not normal? And if it's not normal, what could be causing this? Is this landfill impacts? Is this we had a ton of rain and now our groundwater levels are super high and it's causing redox reactions at that soil water interface? Trying to go through and answer those questions. So that leads us to 2 case studies that we have here. First is an active landfill. It's located in Florida. So prefacing all this with the fact that these are based on Florida regulations, Florida interactions, and DP interactions. So the first landfill has semi-annual sampling is required. The client had noticed that there was some exceedances or high results, not necessarily like above primary, secondary drinking water standards, but also exceeding the norm of what was considered background levels for the site. They noticed that this was occurring in their semi-annual groundwater sampling, and that's when SCS became involved. So first off, they noticed leachate indicators. They noticed ammonia, chloride, sodium, and they asked SCS to help figure out and document these trends. Excuse me. We came in and said, okay, are these parameters increasing in tandem? Are we noticing increases in ammonia, chloride, and sodium every month or every sampling event? Is it one parameter? Is it none of these parameters every month and it's only seasonally? Coming in and asking and trying to determine trends. Are we only experiencing leachate indicators in exceedance during, seasonal high of the groundwater table, or is it only during the seasonal low? Kind of determining if this is something that is due to natural impacts or is this due to landfill impacts. And same with the metals. These are the 3 primary metals that were noticed at the site. You had vanadium, arsenic, and iron. A lot of times, these metals were already above the normal, like FDP, primary and secondary drinking water standards. Their background levels were already high, and then noticing that their semi-annual started tracking where vanadium, arsenic, and iron started exceeding those background levels led to the client being more proactive and asking SCS to get involved and track this along with the leachate indicators to basically get ahead of determining if there is any landfill impact or is this just naturally occurring based on the site. So SCS helped the landfill kind of work through these now what questions. Now that they have these parameters that they're tracking, what are the trends saying? What is historical data saying? SCS came in and helped evaluate these trends and establish that the site is near prior industrial area, which has over time has led to some disturbances and allows for increasing mobility of a lot of these metals in the groundwater. That, along with tracking of groundwater trends, shows that there was a good amount of fluctuation within the groundwater levels over time, and showed that during seasonal highs, you did notice these metals becoming more mobile, but during seasonal lows, you did not notice it as much. So ultimately at the site, FDP did take notice of these trends and did respond to the site regarding their semi-annual data. And they noticed the uptick, which is fine. And the site was very proactive and very transparent with what was happening and allowed for DP to issue evaluation monitoring at this site. So I will talk about that in the next slide. So evaluation monitoring was issued by DEP. Basically, it allowed for additional sampling at the site, which was quarterly sampling for certain parameters, these leachate indicators I talked about, as well as those metals noted previously. It allowed for the site to have increased sampling of these parameters and ultimately of more data, more tracking, understanding where the source is. Is it the landfill? Is it redox reactions? Is it something else? SCS helped compile and submit a evaluation monitoring plan that outlined the early rationale for these increased parameters, as well as started the additional sampling timeline for the site. They were in quarterly monitoring on top of their semi-annual monitoring for these additional parameters. SCS also came in and helped do duplicate sampling to verify laboratory results, making sure that, ruling out that this was a laboratory error versus a a sampling error or any of those things, as well as going in and reviewing historical background data, comparing it to current trends, being a little bit more in depth than just creating a tracking spreadsheet of, okay, in February it was this amount, in August it was this amount. It was going through and determining parameter to parameter comparison. Okay, so are all your leachate indicators tracking upwards? Are only some of them? What seasons are they tracking? And determining that, and then adding in these quarterly data points to determine trends even in recent time compared to historical. So the outcomes of this is that this site is no longer under an FDAP consent order. Yes, they are still in the quarterly monitoring, but it's only because that timeline that was established during the plan is still ongoing at this time. SCS helped navigate the client through the evaluation monitoring, helped determine and provide preliminary rationale as to why this was not due to landfill impacts, but rather due to naturally occurring processes. We helped provide rationale for reducing the number of wells. So instead of it being the entire site under quarterly sampling, we have upwards 20, 30, 40 wells, we're allowed to help the client basically provide rationale as to why it should be only in this specific area where the initial upticks were noticed. So reduce the number of wells that would be part of this evaluation monitoring, as well as focusing on a specific area and overall helping identify any migration patterns and any background levels that could help justify why this was due to naturally occurring processes rather than a landfill impact. In all, the client was able to avoid active remediation, which we all know is costly and is not generally one of the best outcomes regarding finances. So it helped allow for the client to use monitored natural attenuation and sampling to track the plume and to track any contaminants that were being noticed without having to be actively remediating the area. So next case study is a closed landfill. So that was an active landfill that was undergoing current filling operations with semi-annual reporting, and now we're shifting over to a closed landfill. So this landfill is also located in Florida. They are currently under a consent order, which leads to them having to do semi-annual groundwater sampling. Again, similar to the active landfill, they noticed an exceedance. They noticed some parameters that were higher than primary and secondary drinking water standards, as well as background levels. The first, what they noticed were volatile organic compounds, primarily vinyl chloride, 1,1-DCE, benzene, and xylene. So ideally, as mentioned, volatile organic compounds, or VOCs, are due to landfill gas issues. So this site originally did have a passive gas system, and it had some landfill gas issues at the site, which have been addressed at this time, and determined that these landfill gas issues ended up being the source of some of these VOCs that were detected in groundwater. And now SCS is helping to determine the impact and possible dechlorination routes that lead to these parameters becoming dissolving and working their way out of the groundwater and not becoming an issue at the site. So currently the site has an active venting system. It does not currently have a flare at the site, which doesn't necessarily impact the conversation, but leads to the idea that the issue, the source of the landfill gas that was entering the groundwater, has been resolved. It's now just doing the cleanup effort of monitoring what has already been entered into the groundwater. So SCS's role, basically, in here, SCS was brought on to help do the semi-annual data review and reporting. We necessarily didn't sample ourselves, but we went through and reviewed the lab data, came up with the rationale as to different parameters that were noticed in different wells, and kind of monitored the different depths of the parameters affecting different groundwater levels, as well as performing a statistical analysis. As part of this analysis, we used the Mann-Kendall statistics to reduce wells being sampled, as well as the frequency. And some of the wells that demonstrated low VOC concentrations or were presenting a decreasing trend over a series of sampling events In all, there were about 15 wells removed or reduced to annual sampling via this, and each time the semi-annual is submitted for the site, more and more wells are approved by DEP to be reduced from sampling, which has allowed for cost cutting for the client, as well as providing an idea of where the dechlorination efforts or where any type of remediation efforts need to be focused at this site. So that was our first take, is that we helped with their semi-annual sampling as part of their consent order and reducing their well sampling and their well frequency. Our second role at this site was investigator. Basically, we came in and helped determine a sampling plan and carry out sampling for a microbial investigation. The semi-annual sampling provided your chemical justification for the possibility of dechlorination, and this microbial investigation provided that bacterial justification for dechlorination at the site and dechlorination of your volatile organic compounds. So this helped answer that question of, now what? Now that we're noticing VOCs at the site, now what? We have proof that, there's chemical possibility of dechlorination, but doing this microbial investigation allowed to determine if there was a biological presence for dechlorination and if it was possible, and kind of provide a timeline or a rough idea of this is possible in the next 50 years, 100 years, or is it not possible at all. So so we determined that that bacteria is technically lower at the site than should be relative for positive dechlorination. Doesn't mean that dechlorination isn't possible here for these VOCs, but it's just going to be at a slower rate. So ideally, if they were to follow this pathway, they would have to inject bugs or inject some type of food for these bacteria to grow. In turn, it doesn't necessarily mean that dechlorination won't happen. It just means that it won't happen at a relatively fast rate, which leads back to continuing semi-annual sampling and continuing these trend analysis and statistical analysis to determine what wells have these compounds present and what wells don't, and monitoring that and reducing frequency based on that. So the outcomes, yes, the microbe colonies in the groundwater were not as high as wanted. However, we were able to answer that biological what if question. Is dechlorination possible? Yes, it's possible. It's not as fast as maybe wanted to, get the site out of the consent order. However, it is possible over time. That, paired with continuing to monitor the chemical side, the chemical what if through semi-annuals, allows to continually reevaluating the data and determining trends and determining what wells can be removed. So it wasn't a lost effort. It allowed for the understanding of what is going on underneath the surface at this site. You can look at the chemical data all day, and then adding in that biological data allowed for a bigger picture to be drawn and to understand what is happening with the volatile organic chemicals in this groundwater. So basically, to recap, first off, remember to cap your wells if you are sampling, because these frogs, spiders, thank God I didn't see any spiders, but these frogs are quite scary sometimes when you're not expecting it and they jump out at you. So remember to cap your wells. Exceedances can happen at any point during the site life. It can be during the active lifespan. It could be during post-closure, long-term care. It happens, and a lot of times it is not due to the landfill itself. It can be due to naturally occurring processes that leach metals or different leachate indicators that could be attributed to landfill, but more likely than not are contributed to naturally occurring processes. And evaluation of your groundwater is key. Knowing and partnering with someone that can understand how to approach these DP responses to provide a larger picture and keep the landfill's best interest is key to being able to facilitate answers and have these open conversations with DEP to determine and justify why this is not due to landfill impacts or landfill operations, but rather due to naturally occurring processes in the groundwater. And with that, I thank you. And if anyone has any questions, please let me know.
Do we have any questions for Fove? All right, great job, Fove. Thank you. We will move on to the next presentation about PFAS. Go ahead, Karim.
All right. Good morning, everybody. Just give me a second. My presentation. Yes. Good morning, everybody. My name is Kerim Temel, and I am with SCS's liquids management team, basically industrial wastewater treatment team. I have been with SCS a little over 10 months. I am fairly new to SCS, but I have been in the business more than 13, 14 years. So we live in a time where the challenges we face are increasingly complex. So when we discover a new useful chemical, which may become a future health and environmental concerns, one of which is PFAS. Today, I'm here to share insights of PFAS. Throughout my presentation, I will walk you through the short background of PFAS, PFAS regulations, and PFAS treatment technologies. Right, let's dive in. So what is PFAS? PFAS is an acronym for per and polyfluoroalkyl substances. As I mentioned, it's a man-made chemical used in making things like firefighting foam, stain repellent, non-stick cookware, waterproof clothing, paint, tile paper, makeup, and many, many more consumer products. So let's talk, this is going to be a really short and only chemicals terms that I'm going to use. So what is PFAS actually? It is, carbon atoms surrounded by fluorine atoms and with different N terminals. On the picture, what you see here on the left side is PO4A, and on the right side is PO4S. PO4A has carboxylic acid N terminal, and PO4S has sulfonic acid N terminal. There are thousands of different variations of PFAS. Currently known amount is probably around 4,000 to 5,000, but EPA estimates this number could go up to 15,000 PFAS compounds. So why PFAS is important? It is persistent, bioaccumulative, and toxic. So how do we end up with PFAS at the landfill? So, there are many, many consumer products end up at the landfill. And PFAS seeps through the garbage layer and breaks down to many different PFAS compounds. Most of PFAS leaves the landfill in the leachate, liquid form. However, PFAS also detected in the landfill gas as well. So while there have been concerns with PFAS for several decades, the concern has grown tremendously over the last several years. This is a rapidly emerging field. The Environmental Working Group periodically posts updated maps showing the locations of PFAS sites. In 2012, there were only about 8 PFAS sites. And 2018, the number raised to about 40 sites. And when we look at the 2024, there were too many dots on the map to count, and some regions are now appearing as solid color. So note that known PFAS sites doesn't mean that PFAS is present at problematic concentrations. PFAS sites include a variety of industrial facilities, both facilities that manufacture PFAS and facilities that employ PFAS, such as airports, landfills, and many others. All right, here come the regulations. So before we dive into regulations, PFAS was discovered accidentally in 2013 by Roy Plunkett and Jack Ribock. Basically, they put the frozen fluorocarbon chemical and compressed it and spontaneously it formed a white waxy solid. So this was the first known PFAS, and as I mentioned, it was accidentally discovered at that time. 1930s and 60s, it was no problem. So everybody was enjoying the consumer products and the ease of use of, the nonstick cookware. 1970s, 1980s, there may be a problem now that the health risks are kind of being recognized. 1990s, 2020s, now, most people start aware of this throughout the news and lawsuits, and now it becomes other people's problem. 2010, 2020, lots of other people's problem. Now we know the health risk and public knows the health risk. And today, yes, we have a huge problem. So now on, I'm going to focus on the regulations which was happened in 2024. So the first one is national EPA finalized the national primary drinking water regulations on June 25th, 2024. One of the key takeaways here is the proposed maximum concentration limits. EPA MCS will set the table for POTW discharge regulations and the requirement rolling downhill to dischargers to the POTW. This will also set the table for landfills to start monitoring groundwater for PFAS and potential remediation requirements. The second rule was CERCLA hazardous substance rule, which was finalized for PFAS and PFAS on July 8, 2024. This is the first direct addition to the CERCLA hazardous substance list in 44 years. EPA has never taken directly designated hazardous substance before designated substance under other environmental laws, such as Resource Conservation and Recovery Act, Clean Water Act, or Clean Air Act. So there are two primary objectives to this role. One is timely cleanup of contaminated sites, and the other one is holding polluters accountable for contamination caused. Along with the CERCLA rule, EPA released PFAS enforcement discretion policy. Note that this policy doesn't mean that CERCLA exemption. In this memo, EPA indicated that they will not pursue action for the publicly owned and operated facilities. Again, they specifically indicated publicly owned, not the privately owned. Additionally, EPA enforcement discretion policy provides no protection over private lawsuits. The third rule was RCRA hazardous constituents rule. EPA proposed, not finalized, adding 9 specific PFAS constituents to the Resource Conservation and Recovery Act hazardous constituents list under subtitle C regs, not subtitle D regs. So what is ahead of us? Currently, EPA is conducting a PFAS study for publicly owned treatment works, influent and effluent. As part of this study, POTWs will collect samples of industrial user effluent. Based on the landfill leachate detailed study summarized in Plan 15, the development of effluent guidelines and pretreatment standards for landfills that discharge their leachate was warranted. So therefore, EPA intends to revise the existing landfills point source category effluent limitation guidelines to address PFAS discharge to those from these landfills. So what we are looking at the timeline, the public POTW study and EPA landfill study, probably this is going to take another 2 to 4 years. Another 2 to 4 years is going to be type of implementation. And we are looking at the systems to be operational around 2030, 2032 timeframe range. Some of the states are possibly more aggressive than the others, as we know that Northeast states. And some of the POTWs, they are actually telling their industrial dischargers not to discharge their wastewater to the sanitary sewer because of the PFAS. And I know few of them actually they are indicating that we are not going to accept your leachate, specifically leachate, because you have PFAS, and they want PFAS concentrations to be equal to or lower to drinking water quality standards at this point. So the best advice right now is start planning right now. So what do? First, we need to look at PFAS technologies specific to each site. Each landfill has unique characteristics. And before we dive into the PFAS specifically, we need to also think about other constituents that may be also problematic to discharge. And we know that BOD, ammonia, metal discharge criteria keep getting more stringent. But today I'm going to focus on the PFAS removal technologies. So I have three separate technologies: concentration, absorption, and destructive technologies. Under concentration category, I listed deep well injection. However, deep well injection is a disposal method. Reverse osmosis, foam fractionation, and evaporation, these are concentration technologies. Absorption, activated carbon, and ion exchange are the more mature technologies. And on the destruction side, thermal oxidation, supercritical water oxidation, and electrochemical oxidation are the more mature destructive technologies. So leachate disposal via deep well injection. So deep well injection is basically taking the contaminated water, for us leachate, and discharge deep into the ground where the porous rock formation of the earth. So it depends on the geology, receptors, and seismicity, and it has a really long and expensive permitting time. And typically pre-treatment, filtration, perhaps ion removal is required, and high pressure pumps are used for some states to discharge, and some states they actually require gravity discharge. And currently, there are some states such as Michigan or Texas, there are some landfills they are actually have deep well injection to dispose their leachate. Now we are going to talk about three concentration methods. So first one is the reverse osmosis. Reverse osmosis uses pressure up to 1800 psi to force a leachate to move through a semi-permeable membrane from a solution to a lower concentration, which means the dirty solution stays one side and the clean water pushes through the other side. Reverse osmosis can remove PFAS and other constituent reduction to a non-detectable concentration in the resulting liquid, while the concentrated portion stays on the other side, and the volume of this concentrated residual liquid could be up to 30% of the total liquid. So if we consider 100,000 gallons per day leachate, we will end up having 30,000 gallons per day leachate that we need to deal with. So if we have a permit, we can recycle back to landfill, which is not the right approach perhaps. We can solidify it, put back into landfill, we can evaporate, decrease the volume, put it back into landfill, or we can dispose off-site. And these criteria can apply for other the next three options, which are foam fractionation and evaporation. So foam fractionation takes advantage of hydrophobic behavior of PFAS. Air is bubbled up through the column to carry the PFAS into the foam fractionation. Basically, foam overflows the reactor and we concentrate the PFAS into the foam layer. Sequential columns further concentrate the PFAS in the second or third column. Similar to the liquid residual, we can apply the same disposal options as I identified in the reverse osmosis section as well. The best part with this foam fractionation, the residual concentration is significantly lower. It is 0.5 to 0.1% of the forward flow. And the negative part is it can only remove PFAS. It doesn't touch any other parameters. The third one is the evaporator, concentration through evaporator. So basically, applying heat source to the liquid column, and it will evaporate the water and perhaps VOCs along with it. And it becomes a slurry state on the bottom of the reactor. So waste heat from landfill gas to energy engines, turbines, or landfill gas can be used for heating the liquid. So just to be aware of fluorotelomere alcohols, which may contain PFAS, can release to the atmosphere. However, some vendors claim that there are no detectable PFAS compounds in the vapor phase. Again, they are just testing for only 8 compounds listed in the primary drinking water regulations. So next options are the absorption methods. One is granular activated carbon. Shorter chain. So basically, this method is running leachate through the activated carbon media under pressurized vessel. Basically, PFAS attaches to the activated carbon and removed from the liquid column. GAC is established for water treatment technology for a long time, and it can remove long chain PFAS fairly easily, but it struggles for the short chain PFAS. So basically, short chain PFAS breaks through faster than the long chain PFAS compounds. So when the breakthrough happens, the exhausted media is being disposed to landfill or regenerated, or basically disposed to the incinerators for breakdown. Activated carbon systems require significant amount of pre-treatment, and we know that the organic parameters can compete with the PFAS. Therefore, preliminary biological reactor might be required, and the solids has to be filtered down to I will say 20 to 50 micron levels. Ion exchange media capitalize on the absorption of the hydrophobic tail and ion exchange capacity of the anionic hydrophilic head of the PFAS. Ion exchange can be used in combination with activated carbon, which activated carbon being the first treatment, then the ion exchange unit, because ion exchange media is more expensive. Just to be aware of high TDS concentration, high metals, or high, the other compounds might compete with the PFAS. So the true analysis is required, perhaps spalding as well. Now let's talk about PFAS destruction methods, one of which is thermal treatment. So basically, PFAS compounds, the carbon, the fluorine compound bond is destroyed by applying high temperature. So 1800 Fahrenheit temperature is required for high chain carbon structures, and EPA actually conducted this study, and at 2500 Fahrenheit, for carbon chain, carbon fluorine bond destructed up to the level of, like 100%. Another PFAS destruction method is the supercritical water oxidation. When we take the water temperature to 374 Celsius and apply 3200 psi pressure, the water becomes supercritical phase. Basically, it is in between a gas and liquid phase, which is ideal for the destruction of PFAS. So this technology is typically used for, the highly concentrated residuals from reverse osmosis, foam, fractionation formate, and it is really expensive operations in terms of power or energy requirement. Another PFAS destruction method is electrochemical oxidation. So basically, in this method, there are two methods, two plates, where we apply the current. So we are running the leachate in between these two plates. Two mechanisms of destroying PFAS. One is which through oxidation, through oxidants. When there is a reaction between these two anodes, the hydroxyl compounds appear to be more present and destroy the PFAS. It is really designed and specific to the highly concentrated and low flow liquids, and the electrodes are really specific and expensive, and complex nature of the leachate electrode fouling could happen, and it is a really slow process and energy intensive. In a summary, deep well injections is the more mature approach to dispose of PFAS. And of course, it depends on the geology. Evaporation can be used, but be aware of the emissions. Reverse osmosis and foam fractionation, it can separate the PFAS. However, the disposal of the concentrated volume is required. GAC and ion exchange could be used. However, significant pretreatment is required. Thermal oxidation can be used. However, due to the energy requirement, it is also challenging for straight PFAS, straight leachate oxidation. Supercritical water oxidation and electrochemical oxidation could be used for the concentrate from other streams. It's a slow process and high energy required. And thank you. I can take your questions at this point. Hello?
Kerem, any questions for Kerem? Right, I haven't seen anything come through, so we'll keep going. Kerem, thank you very much for your presentation and time.
You're welcome.
Next one is Daniel. Take it away.
Okay. All right. Well, good morning, and thank you, Karim. I just want to check everybody can hear me and they can see the first slide.
Yes.
Okay, perfect. So thank you, Samia. Thank you, Karim. My name is Daniel Deitch. I'm a vice president and the leader of our sustainable materials management practice, and I'm here based in Miami. And I've been with SCS for 6 years, and I've been a solid waste consultant for about 30. So my fun fact is that while I've been generating waste since I've been born, my interest and love for it really started when I worked as an archaeologist, which was my first profession after college. So with that, I'm here to share a story, a project that we performed, a solid waste management plan on Norman's Key for a client named Fort Partners. And here we go. What I want to talk about today is just provide you with an overview of the island, some of the site development parties, because it did get a little complicated, the goals and objectives of the project, the facilities that are on the island, how we approached the project, our experience when we visited the site initially, The legislation that we operated under in developing this plan, how we characterized the waste that was being generated during two phases of development on the island, both construction and operation, how we applied a zero waste approach, and how we used examples from around the world to help inform our recommendations for the client and for their development, and the recommendations and some key takeaways. So the island, it's in the Exumas. It is about 55 miles southeast of Nassau and about 210 miles east of the Florida Keys. It's a really long island, kind of shaped like a C, and at its widest, it's not quite a mile long. This island has quite a history to it, and it was the smuggling hub for the Medellin drug cartel. Well, one of the advantages that it had was its physical proximity, and it had a runway, which is still used today. More recently, you may be familiar with this island because it was the planned location for a music festival, the Fire Festival. And while the festival never got off the ground, that was sort of the entrance point for the developer today that saw this as an opportunity to turn this island into a luxury island resort. So there are a number of parties, as I mentioned. Fort Partners is the parent entity, and they had several contracts. One is with ERDL, which stands for Exuma Resort Developers Limited. That is the development company, and they have workers that are still on the site developing the various amenities. They also contracted with an international firm named Pagel. They were the general contractors, and they had subs that operated under the name ISD. And lastly, there is an operating unit called Fort Hospitality, and that is really more directly related to Fort Partners, and there are workers associated with that. One of the interesting aspects is we were brought into this project long after the construction agreements were executed, which presented some significant constraints in terms of managing the waste that were generated during the construction period, because the construction firms were under no obligation to manage the waste differently than what we saw when we first arrived on the island. So with that context, let me set the stage for the goals of the project, and that were ultimately endorsed by Fort Partners. And that is to safely and properly manage the waste that in a manner that would protect public health and the environment, both during the construction phase and the operation phase. And the objectives were to comply with all applicable legislation. When we entered the project, when we were on site, we realized that there was no tracking in place for the waste that was being generated. So I wanted to make sure that they would be able to do that as they rounded out the construction phase and moved into the operating phase, both as to establish metrics for the business, but also to instill a sense of confidence for the Bahamian government. We also wanted to minimize waste generation and maximize beneficial use. So during this presentation, I'll talk a bit about zero waste, which was the lens that we used to think about the waste that are generated and how they could be utilized as resources. And then, of course, as they enter the operation phase, we wanted to make sure that they sort of leveraged this solid waste management approach to help deliver an exceptional customer experience. So here is an overview of the entire island. It is broken into 5 districts. And it's interesting because Fort Partners owns the majority of the property, but not all of the property. There is some private property, and there is property that is owned by the Bahamian government. But on the island, and you can see it on the lower portion of the screen, is the airstrip. It's about a 5,000-foot airstrip. Predominantly, there are turboprop planes that fly in, but they can also accommodate jets. McDuff's Restaurant and Cottages was a long-standing business on the southern portion of the island, and it's still operating today. They also built a deep slit marina, and these are not for or average ships. These are for yachts, 100-foot, 200-foot yachts that draw quite a bit of water, and that is seen on the bottom of the screen. Within that area, there is a yacht club and a general store. To the right of that, and a little bit north, is where the contractors and the subcontractors are living. While they're scaling back their operations today, that has been the area that they lived at while they were developing the site. It's also where the Fort Hospitality or the operations staff live, and there are warehouses and construction yards. And just to the north of the runway is the waste management site. And then there are residential and rental villas in the northern portions, or I should say the northeast portion of this area that they call the Whale Tail, which can be seen here. There are also some rental units towards the bottom. So our project approach, again, this was all in mind with the zero waste lens, is to minimize the waste that's generated in the first place, maximize reuse and beneficial use of material, because as you can imagine, it's very expensive to manage waste off of the island, or whatever comes on is either managed on the island or it is hauled off, either for disposal or recycling. So we had 4 tasks. The first was just focusing on project management. It's really just to keep the team aligned as we perform the other works. The second task was data validation, or collection and validation. And then the third task was actually developing the solid waste plan. And the last task was as requested services, which we've used quite extensively, because there have been matters that have come up that are not really related to any of the other tasks, but were critically important for the client. And that gave us the flexibility to be responsive when they needed us. So the first thing we did is we had to get eyes on the site. So there, again, the 2 main development areas. On the left, you can see the runway, the Macduff cottages, in where the marina is, and the support areas, as well as the construction site. What I do want to point out is just to the north of the runway is the current dump location. And then on the northern and eastern portion is the other area that is being developed for residential uses. Now they have some laydown areas where they're stockpiling construction material and construction debris. But one of the challenges is that these are areas that are far apart, and where they really connect is, at least for our purposes, is where they're managing the majority of the waste, which is at the dump site. I will say that we use GIS as the tool to document what we observed during our site visit and to identify all of the active areas. Really to help us tell the story of how the infrastructure ties together as they move from construction into operations. One of the things that we learned after our site visit was, I think I may have mentioned, that the dump site is actually located on government land, which has proven to be a challenge. And actually, it's one of the services that we're providing now is explaining to the government exactly how the waste will be managed responsibly within that site. So I want to share a few pictures with you, just to give you an understanding of what we walked into. On the top left is some of the housing units for the construction workers. And then the center top and right top are some of the unsorted waste from the construction activities. That continues down in the bottom left-hand picture, which is actually at the dump site, where they were using just open pit burning to dispose of waste, or to minimize the volume of waste, rather really before we started the conversation around how they could segregate the material and beneficially use some of it on site rather than just open dumping. The bottom center picture is one of the construction laydown areas where there is material that is being used for construction, and where the chipped and scratched materials are being stored while they consider how they can beneficially use that on site. And then the bottom right-hand picture is an image of one of the finished units. These are Well, largely they're modular units, but not when you think of a single wide or a double wide, that is not what these are. These are luxury units. They just happen to be shipped in that fashion, and they really are of the highest quality. So I mentioned earlier there are legislative requirements that they had to consider, and most of them are from the Bahamian government. So the Environmental Health Services Act focused on public health. In 2004, the Environmental Health Services Regulation primarily focused on the collection and disposal of waste within the Bahamas. The Environmental Planning and Protection Act of 2019 focused on pollution control and hazardous waste, and the Environmental Protection Act focused primarily on plastic waste. We also use the Solid Waste Management Siting Act, which corresponds to the image that we have on the left of the screen, which is typically in the United States, if you have any solid waste activities nearby an airport, they have to be, if you're flying turboprops, at least 5,000 feet away from the end of the runway, and for jets, to be at least 1,000 feet away. Well, as you can see, the dump site is literally at the end of the runway, and they are non-compliant. So a lot of our focus really was on managing that site differently, recognizing that the regulations in the Bahamas are quite a bit different than we have in the United States. So one of the things that we did is we looked at, how much construction waste is there being generated, and we estimate that there's about 500 tons that is being generated. Here it's shown as disposed on an annual basis. And we started to categorize that so we could think and sort of reframe the conversation around, well, what could we reuse if we maximized the beneficial use of that material? And we believe that we could, by better managing it, the vast majority of that material could be beneficially used on site. As I mentioned earlier, there were no requirements in the construction contracts, or at least the contracts with the employees, to better manage the waste. So while we identified this as an opportunity, and they have changed a lot of their practices, largely the construction phase is winding down without realizing the full potential of what they could have used. And as you can imagine, that has upset the financial pro forma for that phase of the project. We also recognize that we're dealing with varying levels of understanding and really a multicultural context for the folks working on this project. So we also wanted to present to them visually what the waste source is, how it can be categorized, the components within, and then how it might be managed or disposed of differently. And we did this both for the construction phase and the operations phase. And we found that visual representation of data was very, very helpful to the project team. We've done the same thing with the operations phase. And what's interesting is that this being a luxury resort, it is not operating typically at peak occupation or peak census. So the amount of waste and the composition of the waste is dramatically different during the operation phase than it was during the construction phase. But due to the nature of operations of a luxury resort, there is a lot more recyclable material and organic material that can be managed on the island. Well, it's an atoll, so there is a real need for soil amendment. So the composting of organics is critically important. We used a similar visual representation of how we believe the waste can be better managed, and we have shown them that by enacting better approaches, better management approaches, they may not achieve zero waste, but they can certainly move strongly in that direction. And sort of how we shared with them the recommended approach is we broke it into policies, programs, and technologies. One of the advantages that they had is that they control the majority of the island, certainly all of the guests coming in. So they have the opportunity to eliminate, by policy, all single-use plastic, and we've given them, presented them with some proofs and some alternatives of how they might be able to do that. As they were entering into new contracts, we showed them examples of how they could employ environmentally preferred purchasing and procurement. For example, they continue to buy a lot of landscaping material. Well, we have encouraged them to write into the contract that any packaging that comes along with that, at the containers that the plants and trees come in, should be taken back by those vendors. Right? They can do that through contracting. Of course, source separating all of the waste, because once it's contaminated, and you saw the pictures earlier, it then becomes labor intensive to segregate it. And unfortunately, don't have the luxury of readily available electricity or surplus electricity and sorting equipment. So it really would be a manual separation exercise. And then last, using the organics for composting and reusing as much of the organics as they can. In terms of programs, employee training is critically important, raising awareness with their guests, implementing refill and zero waste shopping opportunities, because they do have stores on site, using sustainable restaurant amenities and takeout packaging, and also focusing on the guest room amenities, having refillable materials rather than single-use materials. And then, of course, on the technology side, reusable container wraps, refill technologies, and using a biodigester to manage the pre and post plate restaurant waste. And we used a series of proofs to show them where it has been done in similar environments, whether tropical environments or island environments. So there's a great resort in Bali that eliminated the use of plastic, and we shared with them exactly how that was implemented. In Tilos, Greece, a very aggressive waste segregation approach that allows them to maximize material recovery. There is a proliferation of zero waste markets that minimize packaging waste in the first place, using refill technologies. There are a lot of technologies that are well established and able to be used, as I talked earlier, sustainable products and packaging, using compostable materials throughout the island. And then, of course, using QR codes to engage the visitors and help educate them. So in terms of recommendations during the construction phase, we've made them. They've implemented some, but not all. But certainly dealing with the regulatory approval for the dump site, tracking the data, reducing the packaging waste, developing an equipment investment plan, transitioning away from single-use plastic and using filling stations, and then source separating the material so that can be beneficially used to minimize the amount of waste that is shipped off the island. Moving into the operations phase, implementing the zero waste policies and management system with some of the proofs and examples that I previously shared, in developing their CapEx and operational expense, so they can really have a true sense of what the operations will entail, implementing this sort of system, extensive staff training, and then educating, ongoing education with staff and guests. So some of the key takeaways for us: securing buy-in from leadership up front, because ultimately they're the ones that set the context for what occurs on the island. Using GIS was incredibly valuable for us to help visualize the challenges and opportunities in the solid waste plan, using proofs to help support the recommendations, so it isn't this esoteric, theoretical idea, but it's actually been implemented elsewhere and selected specifically for this plan. Also, making recommendations that reflect what is possible, given the constraints, and because it is the islands, and the sense of time is a little bit different, it's balancing persistence with patience. And with that, I wind it down, and I would love to answer any questions you may have.
Anyone have questions for Daniel?
Okay. Well,
all right.
Hearing and seeing none, thank you very much for the opportunity to share this story with you. And let me pass the screen to my colleague, Kevin Frenak, who will discuss the local government permitting approval process in Alabama.
All right, thanks, Daniel. Go ahead and share my screen here and we'll get started. So Hello, everyone. My name is Kevin Fernock. I am a solid waste engineer for SCS out of our Mobile, Alabama office. Have about 5 years of environmental permitting and solid waste experience. Fun fact about me is that I am a fishing fanatic. One of the main reasons I moved down to the Mobile area, do most of my fishing out of a kayak, and I try to go at least once a week, fish some tournaments, things like that. Today, I'm going to be talking about the local host government approval process for new or expanding solid waste management facilities here in the state of Alabama. For those of you who aren't familiar, this is a process that you would have to go through, as I mentioned, for a new or expanding existing solid waste facility prior to actually submitting your permit application to ADEM or the state agency. So, very important for those of you who operate in Alabama or may operate in Alabama in the near future to be aware of this process. And then hopefully some of the general ideas around engaging with local government, local stakeholders will be universal for those of you in other states. In terms of agenda for this presentation, first going to talk more about what local host government approval actually is. Then we'll get into the regulatory basis and what sort of projects and facilities this is applicable for. And finally, we'll go through the full process and give some recommendations for success. So let's talk more about what local host government approval actually is. So as I mentioned before, if you're going to be siting a brand new solid waste management facility or expanding an existing solid waste facility, before you could submit your permit application to ADEM or the other state environmental agency, you would have to go through this local host government approval process and get this approval. Now, I'll go through the steps in detail a little bit later in the presentation, but just to give you a general idea of what this would look like, you would submit an application to your local government. The local government would review that application. There would be a series of public awareness sessions, public hearings to provide the local community the opportunity to provide their input on your proposed project. And then ultimately the local government, whether that be a county commission, city council, whoever, gets to vote and decide on whether your project will move forward or not. So very, very important for those of you who do operate in Alabama. In terms of long-term planning too, it's very important for a couple of reasons. First of all, when you're looking at remaining airspace and kind of your long-term plan for filling, obviously at a certain point, you'll have to potentially permit additional acreage or even open up a brand new landfill to continue operating. And that will require you to go through this process. And this is typically, we see at a minimum, a 6 to 8 month process. So definitely not a quick and simple thing to knock out before you can, even start your permit application with the state. Second reason this is really critical for long-term planning is that this is really not a deterministic process by any means. Now, what I mean by that is we're used to our permit applications, for instance, with ADEM or the state agencies, where we know that when we're putting these applications together, if we're complying with all the regulations, we're including all the necessary documentation, we have the right plans, calculations, drawings, whatever, and everything's done correctly, that we've checked all the boxes and we know that the state agency will eventually approve our permit application. That is not the case with this process. As I mentioned before, the ultimate outcome of this is that the local government is going to vote on whether they think the project should move forward or not. So you're very much having to not just make sure that you're submitting, a complete application and following the process correctly, but also, being able to convince the local government, local stakeholders, and justify the need for your project. So it can be very challenging. Just to touch on the regulatory basis for this, I just wanted to quickly point out that this is not a process that is written into the ADEM solid waste regulations, for instance. This actually comes directly from the state code of Alabama. So in terms of oversight and enforcement of this program, that comes from the state level at a legislative level. Now, Who does this apply to? What types of projects are going to require you to go through this process? So as I mentioned before, brand new solid waste management facilities, of course, are going to have to go through this. That could be, siting a new landfill, transfer station, MRF, even a composting facility could potentially qualify. So any brand new solid waste facilities. And also I mentioned expanding an existing solid waste facility. So you can see here on the screen these 5 permit modifications that I have listed. These are directly written into the rules associated with local host government approval. So if you're proposing to make a change to an existing facility that corresponds with any of these 5 permit mods, then you would also have to go through this local host government approval process. Now, on the other hand, if you are doing a permit modification that's not listed here, you do not have to go through this process. So now that we kind of have an understanding of what types of projects would qualify, I'll kind of go through the general process start to finish. So as I mentioned before, this can be a very time-intensive process. You're looking at 6 to 8 months minimum. So your first instinct might be to say, well, let's go ahead and get our application in ASAP, get the process started, get that timeline going, as soon as possible to make it go very quickly. But that's usually not the recommended way to approach these things. As I touched on before, it's not a matter of simply going through all of the necessary steps with this process. You're going to have to be engaging with the local government, local stakeholders, and convincing them about your project. So as much background research that you can do and preparatory work is really going to pay off once you formally kind of start that process. So just a few questions I have here on the screen to kind of ask yourself before you would go about preparing that application to submit to the local government. First of all, have you researched the local solid waste management plan? So every county is going to have their own solid waste management plan. In some cases, some cities in the state of Alabama have their own. So you want to make sure that whatever you're proposing to do, whatever type of facility you're proposing to site, is allowed in that solid waste management plan. And the other thing that this is going to help with is that plan is going to provide a blueprint for how this local host government approval process should go. It's going to outline all the steps involved, what needs to be included in your application, and all the information that you're going to need to have ready. So really important to review that, make sure it's up to date and it's compliant with your project. Second of all, we recommend that before you even submit your application, go ahead and engage with the local government that's going to be involved with your project. Obviously they're ultimately going to be the decision makers, right? Voting yes or no on if this goes forward. So it's really important to get involved with them early, educate them on the process, and try to get them on board with what you're proposing. And kind of the second way this can help is if they are on board. Obviously, a big aspect of this process is communicating with the local community, engaging with them. So the local government should be able to provide you guidance on, local community leaders, events you can attend, things like that. So you can really start to connect and engage with the community ahead of time. And finally, do you have a basic plan for the siting and operation of your facility? So I don't mean by this, we don't need engineering drawings or operation plans, things like that at this stage, but you need to have a general idea of where your site's going to be going, what you're looking like in terms of potential acreage involved, what type of facility is it, what waste are you going to be handling, your maximum daily tonnage, service area, things like that, because all of that's going to be information that you're going to need for your application. So once you've got your preparation done, you feel like you're ready to kind of initiate this process, you'll put together the actual application that will go to the local government. Now, this could vary slightly from county to county. As I mentioned before, that's why it's really important to review that local host government solid waste management plan ahead of time to find out if there's going to be any specific details in the area you're proposing to site in. But generally speaking, it's going to include these 3 sections I have listed on the screen here. So first of all, applicant information, of course, who you are, who's going to be owning the landfill or solid waste facility, who's going to be operating the solid waste facility. Have you owned and operated similar types of facilities in the past? Have you had any compliance issues with facilities you may have operated in the past? These are all things the local government's going to want to know. Facility information, as I just touched on at the last slide, what types of acreages you're looking at, the types of waste that you're going to manage, tonnages, service area, all those things need to be included in this application. And then finally, this third bullet here, and this is kind of the main crux of the application that you're going to be putting together, is a written document or a written report, which is going to discuss your proposed project, proposed facility in the context of these 6 criteria that I have listed here. And what this is mainly about is A, justifying the need for your facility in the area, and B, what are the impacts going to be on the local area. So you can see in terms of justifying that need, obviously your facility has to be consistent with the local solid waste management plan, as I mentioned before. Location relative to producers of waste. So for instance, if you're in a very rural, low populated county that already had 2 MSW landfills with decades left of airspace, it's probably going to be a hard sell to say that you want to cite a 3rd potential MSW landfill in that area if there's not sufficient need for it. Development and infrastructure. So for instance, where you're proposing to put this facility, what are the roads like in that area? Is there water connection out there? Are there sufficient firefighting services? These are things that the county may have to invest in ahead of time in order to support your facility. So they're going to want to know, what's kind of some of the potential costs from their end in order to support this project. And then finally, in terms of impacts on the local community, obviously from a public health and safety perspective, especially for something like an MSW landfill, that could be a concern if you have a bunch of shallow drinking water wells in the area surrounding where you're proposing to site this, right? That could be a cause of concern for the county. And also social and economic impacts. If you've got dense residential development nearby, things like impacts on property values, stuff like that. All of these types of factors are going to be evaluated by the county, and you need to be able to provide evidence that all these factors, are being addressed and are not going to be a negative net impact on the county or the city as a whole. So if you've prepared your complete application, now you submit it and you kind of formally start this approval process. So I'll kind of go over the steps involved. So of course, after you submit your application, the local government will review the application, make sure it's complete. You've included all the necessary information and documents. And following that, they'll issue a public notice. This is basically just to put it on the radar of everyone in the local jurisdiction that, you're proposing to site this new facility in this area or expand existing facility, and kind of make them aware of that. If it's a brand new solid waste facility or a major expansion, as you can see with the asterisk I have at the bottom of the screen here, there are a couple of additional steps involved. So one of those would be a public awareness session. And this would be kind of your first step as an applicant to kind of go in front of the public, talk about your proposed project, what you're intending to do, and kind of start engaging with those stakeholders on that end. Following that session, there'll be at least one public hearing involved. And this would be the step, of course, where the local community, the public, would have the opportunity to provide their input. If they have comments on the facility or the expansion you're proposing, or if they have questions about what you're doing, this is going to be the chance for them to speak up here. And this is really that critical step where you're really going to want to have prepared and done your research ahead of time, starting this process, to know who you're going to be dealing with in the community and what some of their potential concerns might be with whatever you're proposing to do. So following that hearing, of course, the local government will take into account all the comments received from the public, and they'll perform kind of a final review of the application. Again, going through all the information you provided, those 6 criteria I talked about on the last slide, and ultimately they will have a vote to decide whether to approve or deny the project going forward. And so for permit modifications, that's kind of the final step of the process there. If you get that approval, you're good to go to move on to putting together your permit application to the state. Again, for brand new solid waste facilities or major area expansions, there's one more step involved, which is a circuit court review. Now, this is not a review of your proposed project or what you're proposing to do specifically, but more just kind of a general oversight from the state to make sure that the rules were followed correctly, the proper process was completed, and the county didn't skip any steps or anything like that. So assuming that, you know, everything was done in accordance with the rules, the circuit court will issue the formal approval. And at that point, for brand new facilities or major expansions, you would have that local approval in hand and could move on to your state permitting. So that's kind of a general overview of the process from start to finish and the steps involved. But just in summary, of course, you know, this is really an important process to be aware of for those of you that do operate in Alabama or may plan to operate in Alabama in the future. Really important to be aware of this process, even for existing facilities, right? Everybody's going to run out of airspace eventually, and at some point you're going to need to look at your options, whether that be permitting additional acreage or even opening up a brand new potential landfill or facility to keep operating. So this process is really one of the primary barriers in place right now to getting those things done. So you really want to make sure that you're aware of all the steps involved and what some of the issues that you're going to be facing. Because like I said before, this is not the typical technical problems, check all the boxes that we face with our state applications. This is very much more of a political and public relations type of process you have to go through, where you're having to ultimately justify the need for your facility to the local community. So it can be a very daunting challenge for sure, especially in today's environment where, you know, social and environmental justice issues are really getting to the forefront of people's minds. But as long as you have a good understanding of the process, the steps involved, and make sure that you're doing the necessary preparatory work and research ahead of time, you can really maximize your chances of success going through this process, get that local approval you need, get your permit, and be well on your way to constructing some more cells. So that is the conclusion of my presentation. Thank you all for your time, and I'd be happy to answer any questions any of you might have.
Kevin, one thing that I wanted to ask you, so is there a difference between, you know, this process for publicly owned versus privately owned landfills?
Yeah, that's a great question to ask. So as things are written in the rules, there is no difference. It's the same process that you'd have to go through, whether it's a publicly owned facility or privately owned. But in practice, of course, the process is generally a lot easier for publicly owned facilities because they have a lot of those existing relationships and understanding of the local community that they're going to be working in. And in cases where it's a county landfill having to get approval from their own county commission, that's usually a much more straightforward process than an outside private, you know, entity trying to come into an area and get approval that way. So it's the same process, but definitely can be a lot more challenging on the private side.
Time for more time.
Yeah.
Any other questions from anyone? All right, thank you, Kevin.
All right.
We move on to our next presentation. Modern GCCS design by Shashank and Kyle.
Hey, can you guys see the screen? Okay, perfect. Well, good afternoon, everyone. Myself and Kyle will present on modern GCCS design. I'm Shashank Patel. I'm based out of the Atlanta office. I've been with SCS for 6 years, and I also help the group as a landfill lead here. Kyle?
Hi, I'm Kyle Manelli. I'm a solid waste engineer out of the Tampa office, and I have been with SCS for 3.5 years now.
Okay. So as we go through this presentation, we will try to answer these three main questions, which are: why is modern GCCS design important? what does a modern GCCS design look like? And then finally, how do we transition to implementing the modern design in the field? So let's get into it. So let's discuss the first one. Why is this modern design approach important? So before we get into design, let's talk about how our landfills are changing. Structurally, older landfills versus today's landfills. Older landfills were smaller and shallower, not a lot of engineering thought behind them. Today's landfills are engineered, they're larger and deeper. Well, what happens with that larger and deeper waste mass that we're referring to? The density has been changing. We're looking at a higher density, closer to 1,800 to 2,000 pounds per cubic yard. And that's not just the result of better compaction. Yes, we've achieved that, through technological changes and training the staff, but it's also the increased overall depth of waste column. And on top of it, the consolidation and settlement effects. Furthermore, we are, talking to the group in the Southeast. Obviously, the waste has moisture content, but the geographical location also adds significant moisture content to the waste mass. So changing landfills, let's talk waste stream. How has that changed over time? Alternative waste streams are being introduced into the landfills. We're talking C&D waste, wet waste like biosolids. We just discussed that as part of our composting presentation. As we are changing our lifestyles, the waste stream is also changing. You can see the infographic or the graph at the bottom, where the plastic consumption or disposal at the landfill has increased significantly. This is a data from 2018, but as you can see from 1960s to 2018, we're seeing like a 27-fold increase in plastic waste. And what does that do? That reduces your waste mass porosity. We're relying on gas extraction, and the whole idea behind that is the porosity of the waste helping us. Well, with more plastic waste, the porosity reduces, so it inhibits the movement of gas as well as liquids, and we'll talk more in the future slides. So how is it impacting us? The key thing that we're seeing here is our landfills are getting deeper, denser, and wetter. And what kind of impact does it bring to the landfill gas and liquid? So as we discussed, it increases the buildup of pore pressures and promotes abnormal emissions and odors, but it also limits the movement of landfill gas and liquids. We're seeing more and more lensing issues due to the soil in the area, but as also plastic waste being present in the landfills. So let's move into what does a modern design look like, and I'll pass it on to Kyle to go through the next slides.
Thank you, Shashank. So before we go to modern design, let's review conventional design. Conventional design involved installing vertical landfill gas extraction wells and horizontal collectors into waste after it was already placed in a cell. With modern design, the idea is to have a real-time installation of landfill gas infrastructure. By real-time, I mean we are concurrently installing landfill gas infrastructure in a cell along with the waste. So here are some examples of modern design GCCS infrastructure. We have gabion cubes, we have horizontal and slope collectors, bottom-up collectors, and we have interconnection to the leachate system and floor collectors, which is a configuration you achieve when you install a combination of the previous three modern designs. So let's go through the design and construction photos of some of these installations. And we got all these pictures from fellow SCSers, so good thanks to all of them for that. All right, so the first picture we have here is a gabion cube. As you can see, it is installed right above the cell floor over the leachate drainage gravel layer. Next picture, you can see the gabion cube is being filled with stone. This stone will help promote gas collection and drainage to the bottom of the cell once well installation has occurred. And in this next picture, you can see the stacking of the gabion cubes. When stacked, the new cube is about 20 feet wide, 20 feet long, and it is a minimum of 15 feet high. And finally, you can see fill operations around the gabion cube. So the idea with the gabion cube is once the fill reaches optimal height, you would drill vertically until you reach the cube. Install a vertical landfill gas extraction well that is connected to the cube, and this would promote liquid drainage down to the bottom of the cell while concurrently promoting gas extraction from the bottom of the cell. So, I mean, some of the cons of the Gabion cubes are if cover isn't adequately applied around it during filling operations, it can lead to landfill gas emissions. And also, due to all the stone that's required for insulation, it can be a bit pricey to install. However, they are a very useful tool for promoting drainage to the bottom of the cell and collecting gas from the bottom of the cell. So next up, we have bottom-up collectors, also known as caisson wells. So a caisson well is a vertical extraction well made entirely of perforated pipe that is surrounded by a protective solid pipe that is filled with stone to promote gas collection. And then here's a picture where the caisson well is being extended vertically. This allows for a perforated pipe to be extended in addition to the outer casing. This vertical raising does require a good amount of manpower, an excavator, and it does involve a good amount of coordination with operations, which can make the extension of caisson wells a bit difficult. However, the caisson well design itself does allow vertical extraction wells to maintain a radius of influence in new lifts of waste, which is very useful as cells are being filled. And next we have horizontal and slope collectors. So most of us are familiar with horizontal collectors. It's a lateral installation of perforated pipe and the landfill deck. And once that perforated pipe is covered with waste, usually the collector is brought online and brought into the system. When these horizontal collectors are installed on a slope, they're classified as slope collectors. And here you can see two snippets from a slope collector design. So here we have a picture of the installation of the slope collector. As you can see, it's a perforated pipe being installed on a slope. This variation of modern GCCS design is very instrumental when installing gas collection infrastructure in new waste, shallow waste, and odd waste configurations such as valley fills and sliver fills. And here's the final collector we're reviewing today. We have floor horizontal collectors. These are installed in the protective cover layer at the bottom of the cell before waste is placed. These collectors have an easy installation, and since they do not require trenching, and they allow for early collection at the bottom of the cell. So horizontal slope collectors, they offer several advantages. They help create drainage pathways to the bottom of the cell. They typically are consistent producers of high quality landfill gas, and they can start collecting gas from waste as soon as it's placed and as soon as it's covered up. The only downside to horizontal and slope collectors are they do require close coordination with operations during installation. That can be kind of a headache whenever you have a fluid cell design or cell fill going on. They do require a stockpiling of materials, which can be a bit expensive, and they also can create odor issues if adequate cover isn't installed around it. But overall, they are a very useful tool for early collection and to install landfill gas infrastructure in areas that are otherwise not uniform or not are pretty hard to install vertical extraction wells in. And with that, I'll hand it back to Shashank.
Thank you, Kyle. So let's look at the summary, right? What a modern well field infrastructure looks like. So as we looked at the pictures of installation and the design approaches, we're talking from the infrastructure will be starting from the floor of the cell, which is your protective cover layer, and then you extend it up the slope, or even in a vertical column of waste. So that way you allow that lateral drainage of liquids. The idea is sound, which is to allow liquids to drain down to your protective cover sands and allowing the gas to flow to your extraction point, which is your wellhead. If you've missed out on the opportunity as part of a cell construction event, there's no harm in starting at an intermediate elevation of waste. The intent is the same, is to drain the liquids out. Fundamentals in terms of engineering aspect, it's the spacing of the collectors that we will discuss. So several of you may have heard the term ROIs, which is the radius of influence. Same thing applies to our horizontal or slope collectors. We're looking at 100 feet center to center spacing and 30 to 50 feet spacing on vertical lifts. Same backfill as non-calcareous rock so that we are providing that porous media around the pipe for gas extraction. Now, how do we implement this design? We talked about the concept. We went into the background of, why we need this as a potential solution with changing landfills. So implementing this design, we discussed the impacts of our deep, dense, and wet conditions. The challenge is, partnering with site operations, and that's where the implementation comes in. It requires close communication with fill operations and prompt response by construction and O&M crews, which, is, as we all in the industry know, is a struggle. An engagement from all parties and buy-in will be required when you're talking about these early collections. You require the fill plans and gas sequence plans and everyone to buy into this process so that when we implement it, we're not in a challenge here. Let's look at some changing, this snippet shows a changing environment at landfills. The first snippet shows how it's a new cell. We talk about gabions and slope collectors, and its transitions into a fill of waste coming in. And then once they reach the final elevations, we can go back and install the conventional gas infrastructure. So it's not going to be a standalone solution for us with these modern designs. We will start off with collecting that early gas, but then we will piggyback with our conventional gas design so that we can collect gas from the waste lifts above it. Like everything else, we have to understand the financial mechanism. How do we finance this, right? So unlike our typical gas expansions in the past, which has been a singular event, or if you reach your regulatory deadline, which is either 2 years of achieving a final slope or 5 years of putting waste in a new cell. Early collection dictates that you plan ahead during your cell construction events and follow up with that financial mechanism. To wrap it up, key takeaways, we discussed our effects of deep, dense, and wet landfills. What does a modern GCCS design look like, which is concurrently installing the gas collection as your waste placement goes by. So it's real time. You can collect that early rich gas, provide that gas to your, if you have an end user, if you're trying to meet the gas quality. And then drainage pathways for liquids. You're wanting to have the liquids drain down. We've seen the challenges with vertical wells, where we have to put pneumatic pumps, and the gas collection is sporadic depending on how we dewater those structures, versus if these structures installed and maintained properly, you won't have to worry about maintaining or installing a pneumatic pump, but allowing liquids to drain down and let the gas flow to the wellheads. And like everything else, plan as the team, plan for your fill operations, plan for your gas collection infrastructure, and then most important, plan for your budgets. And with that, we'll take questions.
You have time for a couple of quick questions, maybe?
Sure.
Stephanie.
Hi, yeah, great presentation, Kyle and Shashank. Just quick question on the Gabion cubes. There was a riser in the Gabion cubes. What was that riser?
Was that pre-installing the Gabion cube?
Yeah, during the show photo.
So the intent for that is, you install vertical perforated pipes, and then if you want to eliminate what the challenges that we saw that Kyle brought up is either emissions or odors around the gabions, you are having these perforated pipes which are vertically in the rock casing, but you run it on the floor and stub it up on the side slope with a vacuum collection point, so that way you have that option of collecting gas early on before you can drill to it.
Okay, perfect. Thanks.
Okay.
My name is Donovan Dickey. I've been with SCS for about 7 years, in the industry for roughly 10. My background is in CQA and well field tuning. I'm going to be presenting on well field monitoring and tuning theory. So I'll go ahead and hop right into it. So why do we tune or balance well fields? We want to try to control and prevent odors. We want to prevent landfill lateral migration of landfill gas, keep our landfills in compliance, prevent subsurface fires, which is the big no-no word that Layla and Stephen presented on, eliminate SIMS exceedances, reduce hazards for our landfill employees, prevent groundwater contamination, and then maximize the landfill gas that we use to send to the landfill gas to energy projects. So while we're tuning, we're looking for exceedances for our federal and state compliance. Currently, what is recorded is temperatures greater than 131, or for some landfills, they have the parameter of 145. And then we want to make sure our pressures are negative and never are positive for our compliance. Once we do our tuning event and we see that we've triggered some of those exceedances, then we go into our remonitoring timelines. For initially, it starts our 5-day exceedance, and you just have to re-record and make sure that the temperatures go down and that we're not positive. And if we are able to achieve that in 5 days, then that is considered remediated and there's no further action required. After 5 days, if those exceedances still exist, then we go into our 15-day. Same thing, we try to do some stuff to make sure that those temperatures go down, or we're able to get those exceedances to remediate. If we're not, then we trigger our 60-day root cause analysis, which we will try to figure out why we have high temperatures or positive readings, and we will make sure that we do some corrective actions to get these exceedances to go away. If we can't do that within 60 days, we will do a 120-day timeline where we do some sorry, guys, get nervous. We will get into the 120-day where we will do some expand the system. So how do we get these remediations, or how do we remediate these exceedances? So we can do tuning by adjusting the vacuum, apply vacuum to the wellhead to adjust our flow so that we can get negative vacuum, add additional cover, de-water the wells, and then we can reestablish vacuum if we've lost vacuum due to water in or some damage has happened to our vacuum lines. Or we can do administrative requests. This is something that our engineers would work on, where they would ask for the additional timelines, get the higher operating values for temperatures, and then we can have alternate operating procedures at the wells by like doing burps. If we have wells that have a lot of gas sometimes, but then they have no gas other times, we can get these different variances to monitor these wells. So our typical workflow for a wellfield technician when they show up on site is to calibrate and bump test their four-gas meter to make sure our employees stay safe. And then we will calibrate our gym and make sure that it's in proper operating order. And then we go and we will monitor the flare to see what our baseline readings are for the entire wellfield. Then if we have time, we'll review the data before we go out in the field for each individual well, so that we have an idea of what has worked in the past before we go out, so we can make informed tuning decisions. If all of our equipment's working, we'll get out to the field. If not, we'll do some troubleshooting. Then when we get out to the well field, we want to address high O2 when possible. I know most people, like to look at methane concentrations, but for us, we try to focus on oxygen and balanced gas, because those are direct indicators we'll talk about later in this presentation. And then after we get all of our readings, we'll upload our data, review the data again, so that we can make better informed tuning decisions the next round of monitoring. So when do we expect to see high oxygen? We expect to see high oxygen in the waste mass whenever it's fresh refuse, brand new well. The wellhead is leaking or not operating properly. We have bentonite seal issues around the well. The well casing is pinched, silted, or watered in, or we have too much vacuum at some of our neighboring wells that will influence the wells around it. The second and third option are ones that we can immediately address in the field as a technician. Other things will need engineering assistance to try to correct. So when we're looking at oxygen, we have this basic ratio of 4:1, because atmospheric conditions are roughly 80% balanced gas or nitrogen to 20% oxygen. So this is one thing that we try to pay attention to when we're out in the field monitoring and when we're doing our data reviews. So here's a typical scenario of what we might see. This is a printout from our data, but this is what we would also see on the GEM. We get our CH4 thing readings, we get our CO2 readings, and then our oxygen and balance gas. So we look at these to try to determine the 4:1 ratio. If I go a slide further, we expand upon that. And all the wells that have this 4:1 ratio are an indication that we might be drawing in atmospheric conditions. So what does that look like in the field? So here's a diagram of a brand new well into the waste mass with the atmospheric conditions highlighted in pink and green. So then as a technician, I would tune this well up to get it to go negative. And here's an example of that going negative. We're at 1 inch of the vacuum. We got 57% methane, 0 oxygen. So this is a great well. If I saw this in the field, I would tune it up. And now we're at 2 inches of vacuum, same conditions, nothing has changed. So tune it up again. And now we're at 3 inches of vacuum. Everything still looks good. So we tune up one more time. And now our data is starting to show us that we're getting a little bit of oxygen. Methane has dropped slightly, and we have 9% balance. So this is still a pretty good well in the field. So without making a really informed tuning decision, we might decide to tune this up one more time, at which point you see the methane drops off significantly, and our oxygen and balance gas have also increased significantly. So at this point, we would try to tune down to get back into that sweet spot of getting good gas with no oxygen. And then an example of wells in close proximity to each other. We have 2 wells here that are kind of pretty much in perfect harmony with a little bit of influence between each other. Well 1 in the blue has great methane, no oxygen, no balance. And then well 2 is semi-stable, doesn't have a lot of balance, doesn't have a lot of oxygen. So in the field, we would probably tune up well 1 and then tune down well 2. And we get a better scenario. Now both wells are exhibiting great methane, very little to no oxygen, and very little to no balance gas. Now, what happens if we saw this in the field? We don't know what's happening below the surface. All we have is our data to go by. So we might tune up well 1 and not do anything to well 2. In that case, now we get to where one well is over influencing the other well. And this shows up in our data by sucking away all the methane from well 2. And now we see a lot of oxygen, no methane, high balance gas. So when you're out in the field and you come up on a well that's in a cluster, and one well in the middle is exhibiting great methane, no oxygen, no balance gas, but you have a few wells around it that don't have any methane and high oxygen, then that's a good indicator that we are over pulling one well way too hard. So we need to tune that down and try to get better balance within the well field. So our tuning goals, as a technician, we want to pull as hard as we can, as safely as we can, which translates to maximum flow without setting our landfill on fire. Extract the landfill gas at the same rate it's being generated, and then help to meet our objectives that were discussed earlier to prevent odors, prevent migration, and then help get a lot of gas for our landfill gas projects and maintain compliance. Our nitrogen equals balance gas. So what does this mean? Our GEM cannot measure nitrogen. What it does is it takes percentage of methane, carbon dioxide, and oxygen and subtracts that from 100. Our balance gas is assumed to be nitrogen, but it's important to focus on balance gas because that's our best indication that we are drawing oxygen into the waste mass. Oxygen gets stripped off from near surface aerobic activities, and the nitrogen or balance gas is what shows up on our GEM. And this is due to overpull when we pull too much atmospheric conditions into the waste mass. So we want to try to not do that and make sure that we're keeping our methogenic process alive and well and not introducing a lot of oxygen or atmospheric conditions into the waste mass. So introducing oxygen into the landfill increases our potential for subsurface oxidation or fires. Oxygen inhibits the methane production and methane is only produced in the absence of oxygen. So how does this show up and how do we relate this on our GEM? So when we see our balanced gas of 4%, then that means we're probably pulling in 1% oxygen, even though it doesn't show up on our data set. And then it can go up as if we see balanced gas or nitrogen at 12%, then we're potentially pulling at least 3% of oxygen into the waste mass. And that goes back to that 4-to-1 ratio we talked about earlier. So here are our best practice guidance, even though for NSPS guidelines, we only have to observe the temperature and the positive pressure. We try to abide by these rules while we're tuning to try to keep oxygen below 5%, pressure positive, our temperatures below 131 or 145 for other landfills that are subject to that requirement. And then we want our methane to stay between 48 and 52, typically in that 50 range. And then our balanced gas, we want to stay below 8, and we want to have our flow to be more than 5 and our maximum system pressure more than 10. So here's a general rule that we try to apply while we're adjusting our well field, 10% rule. So if we have 5 inches of vacuum and we want to pull harder, multiply that by 0.1, and that would be an increase of negative 0.5 inches of vacuum. Or preferably, we try to go by flow. And so same rule applies. If we have 30 SCFM, multiply that by 0.1, and that would be an increase of 3 SFM for that well. Here is a well field analysis. This is just a typical data that we would see in the field on our GEM, and what we would do as a technician to make better informed decisions while we're tuning. So well 1, we have great methane, little to no oxygen, balanced gas is pretty low. We would tune this well up. Our temperatures are low, we're in compliance. So this is a great well to tune up. Well number 2, lower methane, balance and O2 are in that almost that 4-to-1 ratio. We're not pulling on this well too hard, so I don't believe that it would be atmospheric conditions being introduced. So we would check our wellhead and our connections to make sure that there's no leak, and possibly tune this one down just a little bit. And then well number 3, methane is low, oxygen and balanced gas, there's little to no oxygen, but balanced gas is pretty high. We're pulling on this one really hard at 45 inches, and that would be an indication that we might be introducing atmospheric conditions, so we'll tune this down. And there's a few other examples. Take a few seconds to look over those as well. So this is a historical data check. This is how our data is presented for like a 6-month well field analysis. This is what we would use in the field to make sure that we're making really good informed decisions. And as you can see, our rules are applied here. If you start with the first one back in 2015, we started at 4.5 inches of initial pressure or static pressure. We had really good methane, no oxygen, and no balanced gas. So we applied our rules and tuned it up just a little bit. And we did that periodically over time until we got to a point where we were at negative 8 inches. And now we started introducing balanced gas and our methane dropped off. So when that happens in the field, our rule is to cut it in half. So you see we drop back down to 4 inches and then slowly tuned it back up to where we found that sweet spot at 6.8. And we have great methane, little to no oxygen, and balanced gas is pretty low. And here's another example of our 6-month well field analysis. So we just take all this data with us in the field, just so we can see how we've tuned wells historically, and just to make sure that we're doing the best practices and make sure that we're not overpulling these wells and using this data to better assist us in the field. So why do we focus on balance versus methane? So, everybody wants to see high methane, but methane is not our best indicator of what the landfill is doing. Balanced gas is our direct indicator of oxygen intrusion, and it relates to the health of the methogenic process. Potentially, whenever we're introducing too much balanced gas that can be more oxygen, which potentially will feed our subsurface landfill fires. And then we want to monitor that balance so we can prevent O2 so that we don't start a fire as a result of our well field tuning activities. So in conclusion, we want to focus on balanced gas instead of arbitrary CH4 concentrations or range. We can better meet our goal of extracting as much landfill gas in a safe manner. And we'll be able to better throttle how much O2 we allow into the landfill, reducing our risk of fires. That, I'm done. So thank you guys for joining us today. You have any questions?
Thank you, Donovan. We do have time for a couple of questions if anyone has one. I was going to ask you, are there any indicators that you see for blockage liquids in gas wells as you're tuning?
Yes. So one good indicator is, like say, we try to focus on flow rather than a vacuum set point, because you can have a well that has full vacuum but zero flow, and that's usually a good indicator that it's watered in, silted in, pinched off somewhere, and we're not able to get the flow of gas represented by showing up the SCFM on the GEM.
Sense. Great. So if no other questions, thank you, Donovan. I appreciate it.
And good afternoon, everybody. My name is Kayla Willette. I lead SCS's GIS group in the Southeast Business Unit. I've been with SCS for almost 8 years and in the industry for 13. And today I'll be talking about GIS and landfill applications. Today I'll provide an overview of GIS software. I'll show some project examples specifically of CQA liquid levels and surface emissions monitoring. I'll show a landfill dashboard, and I'll discuss some keys to success for implementing GIS at your landfill. Traditionally, GIS was only available at your desktop, and a GIS professional could use and access this data. GIS technology has rapidly evolved, and it is now available to just about anyone, anywhere, at any time using the power of the internet. Maps can be created in an online environment, and these maps are easily accessible from a web browser or in mobile applications on a mobile device. One significant improvement with this setup is that users can directly interact with the data and make edits. These edits can be viewed in near real time, which keeps everyone up to date on the latest information, and this streamlines our work and makes us more efficient. Nowadays, most government agencies and private companies have a GIS department and maintain GIS data that we can leverage for our projects. In the field, we use Esri's Field Maps application. Our online maps are accessible through this. Our online maps are accessible through this app, and field staff can collect points, lines, and polygons and add values to those features like water levels. They can add comments, take photos, just about anything. And this has allowed us to go paperless in the field and has streamlined our work. And I will show you some project examples where you can see what Field Maps looks like in action. Another field application we use is Survey 123 when we have more form-like data collection. These can be configured in multiple different ways with drop-down menus, multiple choice options, and even equations that work with one or multiple entries. There are many nice features we can leverage for quality assurance during the data collection process with Survey 123. And we have converted most of our standard forms to digital Survey 123 forms, which allows for paperless data collection. And I'll show an example of a form later in the presentation. Here and in the next few slides, I'll show how we leverage GIS for efficiencies on our construction quality assurance or CQA projects. Here we have existing wells and laterals in gray, and then the laterals to be installed are in the purple. The landfill gas wells to be installed are in red. They start out as red, and then the field workers can track their progress and mark the wells green as they're installed. The other convenient thing about this map setup is that we have all the well schedule information uploaded and visible when you click on a well. So this underlined text right here is actually a link to our Survey 123 well construction form. And by accessing this form through the map, we've enabled it to pull all of this information, this well construction information, into the well construction form. So the field workers don't type any of this information, and this makes the process much more efficient and improves our data quality by reducing human error. So this is part of the Survey 123 landfill gas well installation log. In addition to passing through the well schedule information, we also have equations set up that are running in the background to QC the values that are entered. For instance, at the top here, we have a check to make sure that the solid pipe and the perforated pipe plus 1 foot equals the total depth of the well. If that condition is not true, a red no will pop up, so the field worker knows they need to go back and review those numbers. If the condition is met, a green yes pops up, so the field worker knows that the values are correct. And we do this in a similar way for pressure test forms. The equations that you see here are plugged into the pressure test form, so our field crew don't have to run these calculations in the field when they're hot and tired. Nobody wants to do math like this. And so they can very quickly and clearly see if their test passes or fails. And these forms can be customized to meet any specification. And what you see here are some screenshots of the Field Maps application. This is what our field staff see in the field and on their phones. This is an example of a CQA project. On these projects, we take lots and lots of photos of just about every field activity that happens. The yellow dots on this map are our photo locations. We use the Field Maps app to collect these photos, add descriptions, capture date and time, and we can also classify the photos by activity. And this streamlines our work because now the photo is associated with all the information that we'll need. We no longer dump photos into a folder on our computer, then try to backtrack with our field notes to figure out what was going on, what the description is going to be. So this process saves us a significant amount of time, and our staff can focus on more important tasks. This is an online web application to review the photos. So as soon as the photos are uploaded, project staff can start to review the photos by accessing this app through a web browser. And a PM or any staff with access can edit the descriptions or any information associated with the photos in this app and select which photos to include in a photo log deliverable. And as the photo logs are reviewed, they can be marked as such with the color. This color will change, or the location will change color from red to green, so they can track the photos that have been reviewed. And the nice thing about this is that the team can review photos in context of the project site, and this is often helpful when troubleshooting issues. And this is a project where we measure liquid levels in landfill gas wells. This, again, is the Field Maps app view. The field staff can keep track of which wells they have sampled by turning points from red to green, which is extremely helpful when we have a lot of sample locations like this. The middle screen is the pop-up for each well, and this is where they record their information, and they can upload photos like the one you see to the right to help track any maintenance needs. And this well needs a lot of help here. And this is the view that someone will have of this same map in the office. This is the online map, and they can see the same information that field staff are seeing in the field. They can see the progress of data collection as it happens. They can click on individual wells to see the information collected and any photos. Any information collected can be quickly exported to a table like the one on the bottom left for review or inclusion in a report. So there's no transcribing of data and less lag time to getting results when using these methods. And if there is an issue, a PM can come to this map, see a photo of the problem, and immediately get spatial context for the situation, and can see all of the available associated data without looking for drawings or old reports, which allows us to make more informed and quicker decisions. And then this map can quickly be turned into a paper figure for inclusion in a report. This map shows wells that may need pumps based on field data that was collected. And this is another liquid level example. And the nifty thing about this one is that the previous water level information is available on the app and online. There's also the option to create charts and graphs of your data. These are viewable online and in the mobile application in the field. So this allows workers to identify trends and potential problems or inconsistencies with data on the spot. And this map is used for pump management. It tracks where and when we installed pumps at wells and any additional info that is important to capture. This conveniently keeps all maintenance information about pumps together with the photos included. Again, you can see all of this information in context of the landfill, which can be insightful. And we can even add more data to this map to explore specific issues. And I'll show some examples of this later. And for surface emissions monitoring, we can upload the SIM path so that it's easily followed in the field. And again, workers can mark what has been completed as they go so they can easily keep track. When a worker is using the app in the Field Maps app in the field, the app shows the user's location as a blue dot on the map. And this allows you to be more certain of your actual location as opposed to using a paper map where you're basically taking your best guess. And now I'm going to show a few examples of a landfill dashboard. Many of you have likely seen or used dashboards of some sort. A dashboard summarizes key pieces of information that we are interested in tracking. So dashboards can be very informative and helpful. This dashboard is for maintenance tracking. Field staff will mark the location in the field where they see a maintenance need. And those are the red flags right here. Project staff can see this in the office and plan and monitor the status of these maintenance needs. There is a list at the bottom right screen where they can track the issues. And when these issues have been addressed, the flag can be cleared off the map. But the nice thing is that a history of all the maintenance is still maintained, and that information can be exported to a table if needed later for further review and use. This dashboard map shows liquid levels in landfill gas wells. There are two pieces of information displayed for each well. So the dot in the center is a different color based on the height of the liquid column. Green is lower, and then going up the scale to purple, which is a very high liquid column. And then the donut around each point illustrates the open perforated pipe. So gray is open, and the blue represents the percent of liquid in the well. So looking at this data, the data this way in context of the landfill allows you to see larger patterns. Like we have some kind of liquids problem, right up here. And then at the bottom left, you can track liquid level measurements during the sampling event to see the progress of your sampling. On this dashboard page, we can look at liquid levels in more detail for each well and see changes over time. So this graph at the top left represents the well column and the sampling event data. So silt in the column is represented by the orange. The liquid is blue. Solid pipe below grade is gray. And what we want to see but don't is green, the open perforated pipe. And we also have the as-built information in the bottom right, so you can see all of this information together, and it just helps you make, see the trends and make decisions with all of the information available. And one last dashboard shot. This is a map that displays service frequency for pumps at wells. This can be used for planning. So if you have a pump being serviced over 3 or so times, you might want to plan on replacing that pump. So now some keys to success. First, how are you going to access GIS? And who on your team needs access? So most government agencies and private companies have GIS departments. So reach out to those folks and talk to them. At SCS, we can help you connect to your GIS department so you can leverage your existing resources. And we can also translate the technical GIS and solid waste speak across departments. And then work backwards from your deliverable. We always say start with the end in mind. Many of our activities are driven by regulatory requirements and reporting. So you'll want to consider what your final product is and then work backwards to deconstruct that so that we can make sure your data sets are set up to collect all of the required information. Then we'll consider who is collecting the data and how. Are you using internal staff or a third party? Sometimes we have staff that use gas meters that record data on the device, so we'll want to consider that. We wouldn't want field staff recording data twice in two places. And then what does that workflow look like? We want to maintain the current workflow as much as possible and just add the new tools to this. And all this planning may seem like a lot up front, but it's time well spent and it will save you a significant amount of time on the back end when all of this works together as intended. And then once all of this is in place, what are some big picture goals that we can address and keep in mind throughout this? You'd be surprised what GIS can do, so don't hold back on what you're trying to achieve. Don't just assume it has to be information associated with a dot on a map. Do you want to reduce maintenance cost, reduce methane emissions, build better budgets? All of this information we collect, and we can use that to help answer those questions. We just have to set up this information in a way to inform those questions. And then one important thing to keep in mind is that not all GIS practitioners are knowledgeable on solid waste. So this can lead to frustrations and miscommunications about needs. And I've noticed in my work that solid waste tends to be left out of GIS practices. For example, governments commonly use GIS to track infrastructure and asset management. Landfills contain county assets too, but they're left out of these systems. So reach out, get curious about what your GIS department can do for you. The more we engage and educate others on what we do, the more we can help each other. And again, keeping in mind that the GIS staff you were speaking with may have never heard of a landfill gas well or a GCCS system. And this is where we can step in to help you translate. So to sum it all up, GIS enables on-demand access to project information and real-time updates. GIS allows for increased efficiency and time savings. You can visualize your data in new ways to solve problems. And there are some considerations for access and project setup to be successful. And now I'll open it up for any questions.
Do we have any questions for Caleb? Hey, Dan. Go ahead.
Okay, I don't know if you mentioned it, maybe you did, but as far as access, like we can give access so that anyone can see the maps that we've created for them within their teams, correct?
Yes, most of the time we can. So in ArcGIS Online, we have our online environment. You can connect, from one online environment to another one. And we've done that with many of our clients. So we set up groups and then we can share information, and that information can also be locked down. So like just because we're sharing information across organizations, that doesn't mean all of SCS is going to see it. We can limit who has access to that data as well.
Thank you. Nice work.
Thank you.
Thank you. One other question, Kayla, I know, data security is huge these days, right? So what measures do we have in place? How secure is the data that, our clients might use the GIS platform for?
So it is first off, all of your no information is made public. It can be made public, but we would definitely notify somebody before doing something like that. So 99% of the information that we have on our environment is internal to SCS only. And then additionally, we can limit, what people have access to which map. So you can create groups so that not everybody can, just come across your map and randomly edit things. So you can lock it down for access. Esri, the software company, manages that online environment. And I mean, they're a big company. They're very well known. They have a big reputation. So that information is generally safe. I do not know of any hacking instances. All right.
Thank you. Any other questions? If not, we'll move on to the last but not least, final presentation for our seminar. Thanks.
All right. Congratulations, everyone. You have made it to the end of the solid waste workshop. I would imagine that some of you, like me, carried the iconic Swiss Army knife in your pocket as a kid, or maybe still as an adult, also like me, just in case something needs trimming, snipping, sharpening. During this session, we'll be talking about the airborne equivalent, unmanned aerial vehicles, or drones. By way of introduction, my name is Joy Stevens. I have 22 years of experience in areas including data analysis and management, GIS, remote sensing and drones, and environmental management with a focus on energy. My interest in remote sensing began in 2017 when I took on a special project with the Scottish Environment Protection Agency. I learned that they, along with the rest of the European Union, had been struggling with waste crime, the money-making potential of which has been equated to narcotics trafficking and costs the UK over £1 billion per year. I started researching the role of remote sensing in combating waste crime and concocted a research project to see if drones could be used to detect illegal dumping of trauma fines, which is just mixed waste consisting of materials like wood, aggregate, sand, glass, and organics. I received my FAA Part 107 license in 2019 and have been using drones in the solid waste industry ever since. Over the next 15 minutes, we'll be discussing the prevalence of drones in various industries, the benefits of using them, feasibility for your site, and a few applications. Drones are put to good use in a variety of industries. The top image you see here is an MQ-9 Reaper being used in a training exercise. Other military applications include acting as targets for military training, conducting reconnaissance, or providing mission intelligence and attack like missiles, bombs, explosives. Demining is another application. Drones can inexpensively, safely, and effectively map and speed up clearing of minefields using hyperspectral imaging. The aerospace industry also uses drones in the visual inspection of aircraft or small scouting drones used for Mars exploration, like the helicopter Ingenuity you see down here. Archaeology also makes use of drones in 3D mapping of above-ground ruins, but even drone-based use of ground-penetrating radar like you see in the upper right. They're also used for entertainment and recreation, filmmaking, drone light shows, drone racing, and so on. Drones are also used in agriculture to monitor livestock or crop and water levels using a near-infrared sensor to gauge crop health, as you see on the bottom left. And drones have been used in disaster relief as well, collecting intelligence in dangerous areas, like the Fukushima No. 1 nuclear plant, for example, and wildfire management early detection. We'll talk about some more well-known applications, including surveying, aerial photogrammetry, and LiDAR sensors shortly. Finally, drones are used in a variety of inspections, like power lines here in the bottom right, wind turbines, mining inspections, solar panels, buildings, and roofs, just to name a few. As you can imagine, there are a bunch more applications. If you perform a quick search on the benefits of using unmanned aircraft systems, UAS, you'll see the same batch of bullet points pop up everywhere. Drones earn top marks for efficiency, accuracy, safety, accessibility, data collection, and data quality. Though some of the payloads for drones can be pretty costly, the base costs for drones themselves aren't too bad. The Mavic 3 Enterprise you see on the top right, for instance, might cost anywhere from about $3,000 to $7,000, depending upon the package you select. The Matrice 300 or 350 RTK, this larger drone on the right, has a base cost of around $13,000. Having a small 1 to 2 person team can also cut down on your labor costs. Another benefit to using drones is capitalizing on different sensors to gather information not perceptible to the human eye, like spectral data, LiDAR data, or thermal data, to name a few. The payloads you see along the bottom are the ZenMuse 2 L2 LiDAR, the MicaSense multispectral sensor, and the Pergam Laser Falcon, which detects methane. If one of the applications or benefits I mentioned piqued your interest, you may want to check your site's airspace or ask a certified drone pilot. An easy way to do this is using the Air Control app on your phone or desktop. Enter your site's address to see what kind of airspace is in the area, and even if your site is in controlled airspace, you've got some options. Many, but not all airports support LAANC, which stands for Low Altitude Authorization and Notification Capability. This can mean almost instantaneous approval depending upon a few flight parameters. Remote pilots can also apply for an airspace authorization or a Part 107 waiver for operations like flying at night, flying beyond visual line of sight on FAA drone zone, but this may require a much longer period, up to 90 days, to be reviewed. Next, we'll look at a few widely used applications in the solid waste industry, beginning with photogrammetry, which is just the process of measuring from images, and topographic mapping. As the drone zips along its pre-programmed flight path, the latitude, longitude, and relative altitude are recorded and stored in the photo's EXIF data, which you can view by looking at the photo's properties. When these photos are processed using software like Pix4D Mapper, 3D points called automatic tie points are automatically detected and matched up in images. Then ground control points, which you can see in the upper right here, are just points with known latitude, longitude, and altitude. These are set prior to a flight and are used to geo-reference the model, which means just placing it correctly in space during processing. Once those ATPs are generated and the model is georeferenced with GCPs, it's time to generate the densified point cloud and digital elevation models. The point cloud will be classified into groups, including ground, road surface, high vegetation, building, and human-made objects. Pix4D Mapper uses machine learning to classify point clouds, and it really does a great job. But there are some cases in which manual intervention and editing is necessary. I've had some data sets, for instance, process perfectly, and others which have needed a lot of editing. Once that point cloud is classified, it's time to generate the digital elevation models. On the upper right, you'll see a series of screenshots showing a densified, classified point cloud, a digital surface model, which shows the elevation of all features, vegetation, roads, buildings, and an orthomosaic, which is a high-resolution, detailed image that's created by stitching all the individual photos together. The bottom left shows the digital terrain model, which takes into account only bare earth, and 1-foot contours generated from that model. These models can be used to determine remaining airspace, perform cut-fill analyses, stockpile calculations, slope gradient, and other such measurements. So whereas photogrammetry is the process of measuring from images, LiDAR, which was first used in the 1960s and stands for Light Detection and Ranging, works by illuminating a target object or space with laser light and recording the time it takes the laser light to return to the sensor. Though LiDAR produces only a point cloud, it requires low, slow flights and is often pretty expensive. The benefits are that these sensors produce their own light, so they're not affected by weather, and they can penetrate spaces between pieces of foliage to pick up small details, making this perfect for areas with a great deal of growth. Photogrammetry reconstructs what's only visible on the surface, making this more suitable for areas with sparse vegetation and allows for faster flights at higher altitudes. Another known and growing application for drones in the solid waste industry is methane leak detection. I'll briefly address 3 methodologies: The first, tunable diode laser absorption spectroscopy, which is quite a mouthful. The second, sniffer drone. And the third, gas mapping LiDAR. You'll see the sensor mounted on the bottom of a helicopter here. The first option we'll look at, TDLAS, is based on infrared absorption spectroscopy. The drone you see here is outfitted with a methane sensor, that's the tunable diode laser, a radar altimeter, which enables the drone to follow the terrain at a consistent altitude above ground level. This is typically between 10 to 20 meters above ground level, and SPH Engineering's SkyHub. This laser is tuned to a specific spectral range, specifically 1.65 micrometers, and it emits light, which is reflected back and captured by the sensor. If methane is present along the light path, along the laser path, the light is partially absorbed. The outgoing and incoming signals are then compared, and an algorithm calculates the gas concentration in parts per million times meters. So note, this isn't a point source measurement, but it measures methane along the laser beam. These readings are recorded in SkyHub and shown on the pilot's remote control. There are a few software examples on the screen as well. One is UGCS's software for programming flight paths and gathering methane data during the flight, and the other is ArcGIS Online for interactive displays and exploration of the flight data. Each of the points you see here has a timestamp, location, methane data, and weather data, and the layer you see beneath those points is an interpolated heat map. Another option is Sniffer Robotics' patented Sniffer drone. This method uses laser-guided terrain following to keep the drone at a consistent 6 meters above ground level. Air samples are collected at the ground surface using their patented hosel system, which consists of a flexible hose, a weighted nozzle, and a breakaway coupling. During flight, the drone continuously collects air samples, pumps these samples to the onboard detector, and measures the methane concentration, reporting leak source locations with GPS coordinates at a rate of about 3 measurements per second. An interesting note, this method is EPA compliant for surface emissions monitoring under OTM, Other Test Method 51, as of December 2022. The EPA's letter to Sniffer stated that UAS-based alternative methods, quote, yield results that are typically no less stringent and often more conservative when compared to those of existing SIM compliance procedures, and thus adequate to determine compliance with the operational limit. The last option we'll talk about is really used in the oil and gas industry, but I bring it up because it was very successful in a large-scale controlled release study conducted by Flux Lab on a closed landfill and prepared for the Environment Research and Education Foundation in November of last year. During this study, 16 combinations of vendors and methodologies were assessed for their performance of quantification and detection of methane during a whopping 71 experiments. Gas mapping LiDAR performed really well, detecting all active emitting points, including flow rates as low as 1 kilogram per hour. Gas mapping LiDAR works by transmitting a continuous wave laser through the gas to the ground with a frequency that's known to be absorbed by the target gas. The concentration of gas is then determined by measuring the amount of laser light returning from the ground. The laser pulses emitted are then used to create detailed 3D models and point clouds, which are used to measure gas concentration and determine emission rates. Interestingly, a company that uses this technology, Bridger Photonics, signed a $12 million methane leak detection agreement with SoCalGas in 2021 as part of SoCalGas's mission to be the cleanest, safest, most innovative energy company in the USA. They also partner with ExxonMobil. Moving on to thermal. You'll notice the drone pictured here looks very similar to one I showed earlier, the Mavic 3 Enterprise. The Mavic 3 thermal features an extra camera, a thermal camera, that can measure point and area temperatures. The simultaneous split screen zoom, like you see here in the bottom image, allows for side-by-side comparisons of thermal and RBG imagery. The image you see on the upper right is a thermal inspection of roof-mounted solar panels. Thermal cameras can detect hotspots, which are indicative of higher resistance in the panels, making it easier to find defects or maintenance needs and fix that problem before a component fails. Inspecting flares has traditionally been labor-intensive and somewhat risky, involving scaffolding, man lifts, or cranes. Hence, thermal imaging being incorporated in the early 2000s and drone-based thermal imaging more recently. Thermal imaging on flare stacks can identify hotspots, unusual temperature patterns, pilot flame issues, heat distribution, and more. We're just about to wrap up here, so to conclude our time, I'd like to highlight a few lesser-known drone applications. Drones can be used for water sampling in dangerous or inaccessible areas like mine pit lakes, high alpine lakes, rocky shorelines, contaminated bodies of water, and so on. Earlier, I mentioned drones being used in agricultural capacities as well. That same technology, using a multispectral sensor to capture near-infrared data, allows users to calculate the Normalized Difference Vegetation Index, or NDVI. High NDVI values, about 0.6 to 0.9, indicate vegetation at peak growth stages, vegetation that's nice and healthy. Lower values indicate less than healthy vegetation, which may be indicative of contamination, heat, or other conditions you could find on a landfill, for instance. And finally, drones can be used to combat waste crime in a variety of ways. The top photo shows a drone-mounted thermal camera tracing illegal discharge back to its point of origin. High-resolution drone imagery can also be used to identify illegal dump sites, piles of waste stored behind buildings or trees, and collect data from hostile sites. Drone footage has even been used as evidence of illegal waste activity in court cases. And that brings us to the last few minutes we have for questions. Thank you all so much for your time, and thank you for sticking with us through the end.
Thank you, Joy. Do we have any questions? So Joy, I'm not sure if you went over this, but of all of the drone applications that you discussed, what do we have, SCS has, in terms of service that we can provide?
Absolutely. SCS can capture aerial imagery, we can do topographic mapping, we can take high-resolution photos and video, thermal inspections and imaging, methane leak detection, and even LiDAR.
So many applications I can think of, right? To use
Absolutely. Absolutely.
Any other questions from any of the audience? Joy, Dan's put something in the chat if you want to.
It's almost for everyone else that's on the line,
Right.
No, obviously we do SCMs for many people.
Mm-hmm.
We don't necessarily use that sniffer method. I just wondered if there's anyone in Florida or anyone else on the line that might be able to let us know if they're using it, but maybe not. Maybe not yet.
Dan, I did read an article that I believe the landfill was in Kansas, and it was it was under pressure, and it's been using sniffer drone for its quarterly SEM.
Okay. Thank you.
Absolutely.
Awesome. That brings us to the end of our solid waste virtual workshop. Thank you everyone that joined and was able to stay with us through the end.